Well, good morning, everybody. It's so nice to see you all here this morning. Okay, that's good. I lost my slides. Okay, my name is Gary Langford, and I'm Chief Executive of Eagle Technology Group, and I have here with me this morning Coralie Eagle, who's the Chairman and owner of Eagle Technology Group Limited. On behalf of Coralie and Jack Dangerman, President of Esri, we welcome you all here to Auckland, the city of sales as it's known. It's a city where Eagle Technology was founded 43 years ago by Coralie and her late husband Trevor Eagle. Eagle Technology has been the official distributor for Esri in New Zealand for more than 25 years. Most of you will know Eagle for its GIS capability. However, we also have exhibiting our team from our Enterprise Solutions Group who specialise in service desk, disaster recovery and managed services and infrastructure provision. The team at Eagle are very excited to be hosting the Esri Asia Pacific User Conference 2012. This conference would not have been possible without the support of a number of organisations. It has been a team effort in combination with support from Esri, and it's so great to see so many people from Esri down here for this conference, and also from the New Zealand Esri User Group. It's a significant event for that group because it's the 16th annual New Zealand User Group Conference, and we acknowledge their support and contribution to this program. We would also not be able to run this conference without the support of our sponsors. I wanted to particularly acknowledge the Platinum sponsor, IBM, for this year's conference support and for cementing and strengthening our relationship and shared philosophy to build a smarter world. We also acknowledge our gold sponsors, Esri Australia, Telvent Snyder Electrical and TomTom for their support. I also wanted to mention and give a vote of thanks also to our silver sponsors, eSpatial, Motion, North-South Group, GBS, TerraLink and Splice, and also mention that we have two authorised data providers, TerraLink and Navtech, and many of the demonstrations that you will see today for this event will contain data from these two providers. Thanks also to the exhibitors for helping us make this event possible, and we'll be pleased if you would all visit them on level 4 at the Expo Centre. And this will exhibit the latest in GIS solutions and services. And also need to acknowledge the help from Toshiba for providing the hardware for the Eagle and the Esri stand downstairs. There are over 520 attendees at this conference. That's by far and away the largest GIS conference ever held in New Zealand, and it's fantastic that so many of you have come along to support us. You'll see from the green shaded bits on the map that we have over 20 countries represented at this conference. We also have over 200 organisations present from over 31 sectors, so very representative of our user base. There are a number of housekeeping issues that we need to talk through very briefly. First of all, the Expo, as I said before, is on level 4, directly below this room, at Auckland rooms 1 to 4, where the sponsor and exhibition stands are. It's also where the closing ceremony and the farewell drinks, morning teas, afternoon teas and lunches will be held. It's important that you make your way back up to the plenary rooms or the workshops on time for the start of each session to respect the speakers for that area, and you will be advised by staff and a warning signal to give you time to get back upstairs. We're also encouraging you to use Twitter, and we have a Twitter hashtag, as you can see on the screen, which is #Esri APUC, and that will allow you to interact together. There will also be a live Twitter feed in the expo downstairs. There's a web mat competition. It is now closed for entries. It is still open for votes, however, until midday tomorrow, and there will be a prize presented at the closing session. Parking validation is actually quite important for those of you who travel by car. It's quite expensive if you don't get your tickets validated, so please make sure before you go back to your car that you get your tickets validated at the validation stations on level 4 and 5. For a safety message, you should refer to page 60 of the program. If there is an opportunity for the fire alarms to ring loud, you need to follow instructions of the staff and evacuate immediately. All the exits are clearly marked, and the assembly point is at the bottom of the Sky Tower. We are trialling at this conference an application, a phone app, which is called Show Gizmo. This is informative, and it will enable you to be in touch with the program delegates and sponsors. If you refer to page 59 of the program, that will tell you how to download the app, and you should try it out. Very interesting. The Melbourne Cup is being held today, and its relevance is that it's the theme for our dinner tonight, A Day at the Races. It will be shown here in the plenary session at 5 o'clock tonight. It will only take 10 minutes, and it's an opportunity for you to have plenty of time to get ready for the dinner. The dinner tonight is actually at the Viaduct Event Centre, which is actually about 20 minutes walk from here and possibly 10 minutes by taxi. And it's important that you note that it starts at 6:30 and it goes to midnight. You'll need to have your dinner tickets to come through into the dinner. And it's now my pleasure to introduce Jack Dangermond, who probably needs no introduction. Jack started with Esri in 1969, having earned a Master of Science in Landscape Architecture from the Graduate School of Design at Harvard University. He has several other degrees and 12 honorary doctorates. He is the visionary behind all the things that you are seeing at this event. Esri now has over 2,700 employees and 100 distributors around the world, and it is the leader in the GIS technology sector. Please join with Coralie and I in welcoming Jack Dangermond to the stage. Welcome, Jack.
Hello. Coralie. Thank you, Coralie. Yeah. Thank you, guys. Once again, thanks to Eagle and to Gary and Coralie. They're just amazing people, as many of you personally know. It's my pleasure to welcome you to this meeting. And I think of many of you as my friends and colleagues over the years. It's nice to be back here, actually. Let's just say it up front. You are a special community here. Do you guys all know each other, by the way? I always like to start my talks by having people actually get to know each other better, so do that for me right now. Introduce yourself to one new person and tell them why you're here. That'd be good. Turn around. Good, perfect, thank you. That should give you the evidence that you are a special group of people, right? Interesting. And I'd like you to do that all week. This week is all about you and your work and sharing it and learning from each other. There'll obviously be presentations, some of them formal. I'll do one, there'll be many others. You will do it yourself, but most important, I think, is the dimension of creating friendship. And friendship has been a long-standing human tradition, as a matter of fact. And within the geography community and the GIS community particularly, it's very important because GIS is about integration, it's about sharing, it's about bringing stuff together. And if we don't have a network of friends to learn from, then we don't make much progress. The evidence is quite clear today that the world that you and I live in is changing rapidly. We live on the same planet, we breathe the same air, we have some of the same concerns, and many of these concerns are these. Climate change, for example, or loss of biodiversity, or population growth, or economic variability and globalization. At the same time, many of these issues are emerging and growing and affecting our personal lives and the world around us. We're also living in a time of incredible scientific discovery in health, in understanding how things work. We're creating more technology. It's, again, accelerating beyond our wildest imaginations, and it's creating more data. Tons of data. The whole big data movement is an indication of it. And you, as GIS professionals, will be dealing with it. Yet, we don't have, as a society, as a global society, we don't have an effective way to bring this together. We need more than simply data. And this should be a message to each of you as professionals. We need to have a new language, a language of understanding. And that's what this conference theme is all about. A technology, your technology, for integration of knowledge in the planet so that we can understand. And my good friend Saul Werman once said, understanding precedes action. You, ladies and gentlemen, are in the understanding language, or in the understanding business. Let me start with this. Geography is our platform for understanding. As human beings, it is the foundation science for bringing all the ologies together. And GIS in these early 50 years has made it come alive. It's allowed us to bring our information together, to integrate it, and to turn it into applications which actually matter, that also communicate to people stories about situations or the crisis or all kinds of stories. Your work clearly, as the little video showed and as these slides showed, is making a difference in many fields, in agriculture, in forestry, in emergency management, in land use planning, in responding to things like disasters, in responding to crime, in public safety. Your work is moving into the oceans, seeing the effect of climate change on our coastlines, but also planning for marine protection zones, here particularly in New Zealand, but all over South Asia. Some of you are working in the field of water resources, surficial water, modeling it. Here in New Zealand, you're building a kind of model that we hope will spread around the world for water resource management. You and your colleagues, and there are hundreds of thousands of them, are working at many different scales. Small scales, the building scale, the regional scale. Some of you are actually looking at climate change, as this little animation shows the integration of the 17 IPCC models doesn't look very good into the future. Looks like we're going to get a lot warmer, and that will have serious consequences. This is the aggregation of those models for the next 80 years. And at minimum, if we do everything right, the Arctic will warm up about 11 degrees. That's pretty scary, because it'll have an effect on virtually everything that is around us. That one particularly has got me most nervous. Your work is responding to these kinds of issues, sometimes in micro ways, things like solar collectors on roofs, sometimes in macro ways like protecting nature or reducing energy usage. It has an effect. In fact, I don't know of any technology or any movement or any community that's doing as much about the future and sustaining the future as you are. This is why I'm quite passionate about what we're up to. Why is GIS growing in such a way? Well, there are many reasons. But before we go there, I'd like to simply say that there are those of you around the world who are beginning to put the pieces of GIS together into what I like to call societal infrastructure, a new kind of platform for both understanding but also human action. These examples in China, in Abu Dhabi, in the city of Geneva, where they're building a complete GIS system for virtually everything that happens, and on, represent the collective bringing together of our respective data and knowledge and methods. And I think this has great meaning. But back to the question, why is it particularly growing now? One might argue that it's because of the enormous demand for geographic knowledge. That's part of it. But these five things, I think, explain, at least in my mind, why particularly this year and last year and next year, this will be growing even faster. First, maps communicate stories. And then they integrate information. They integrate our disciplinary data, all of the ologies that I mentioned. Also, analytics are beginning to be discovered, not only in our field, but in all fields, business analytics. And people say, oh, spatial analytics, now they actually know. Quantitatively, they can look at relationships and patterns and create meaning from it. Fourth, a new field is emerging called geodesign. It builds on top of GIS, and it deals with designing the future. It gives us a chance to bring all of our geographic information together and design with nature. And finally, this year, like no other year in my life, the technology is opening new ways to expand what we are doing. So, maps communicate stories. These are 6 little stories that I'd like to share. The map in the lower left is the tsunami in Japan that hit last year. And hour by hour, the tsunami waves are going across the ocean. This map saved lives in Honolulu and perhaps in the west coast of North and South America because it showed when the tsunami would hit. This map was actually made years and years ago. But when the earthquake hit, somebody poured the data into this template and predicted approximately when it would hit. The map in the lower center is a map that was not so prompt. It was the map of the Fukushima nuclear plant. And it shows where the radiation spread, how the radiation got into the milk supply and food supply in Japan. This map was not made public, and as a result, people didn't evacuate the right areas. They evacuated 4 kilometers, but the map itself didn't really go public for about 4 months. The third map, showing hotspots in South Africa, is a map that illustrates where we should conserve lands for biodiversity. And the map in the center is showing where the World Bank is spending money this year. You can see a lot of it going into southern Greece. Or the map above that is an analytic map showing where a large retail store shows where they can get the best profit. And then the climate change map is quite obvious. Each of these maps are designed to tell a story, a kind of map story. And this last year, National Geographic's head of cartography joined our staff to start a new adventure of storytelling maps. These maps are by design designed to tell stories. And they're out on a website called, I think, Map Stories, or Story Maps, I can never remember. And they not only are the stories, but they're also templates that you can download and use yourself. And some of you here in New Zealand have been doing exactly that thing, putting interesting stories on local content and sharing it both in press and also on the web. The second reason why GIS is so compelling is the integration power, that is, bringing data from different sources together so that we see the whole. And then, of course, back to visualization, helping communicate the whole. And third, GIS helps break down the barriers between different disciplines, like all the ologies, the hydrology or biology or geology or anthropology or sociology. All of these things can be brought together through map integration. And number 3, Analytics. Not only can we bring the data together in space, but we can also begin to analyze those patterns that tell us something, that create understanding of what's going on. And your work is a testimony to exactly that, whether it's in agriculture or land use planning or transit or shipping or the whole story. Fourth, geodesign borrows from the idea of landscape architecture, my original field. The idea is that we bring geographic layers together and we design on them. But this isn't landscape architecture. This is geographic architecture or geographic design, creating more sustainable outcomes, more sustainable cities by integrating the very data sets and using the same technologies that you use, creating alternative designs that can be quickly evaluated in terms of their consequences and then moved on. That field will not just be a design field. All of you will become designers, leveraging the integrated information that you are creating to support better outcomes in your organizations. Finally, the main aspect of my talk this morning is new technology is extending your work, extending GIS. Certainly the pattern of desktop created a huge expansion. There are now over 1 million desktop users using this pattern, and they use it every day with their own local data or now increasingly data off the web. And the server pattern allowed broadcast out of information and to some extent crowdsourced information back into a server. The enterprise environment, pioneered initially by IBM, bringing enterprise service buses together with SOA, allowed us to plug geo-servers in with other kinds of servers like ERP or CRM and unify business practices. These three patterns many of you are doing. But in the last couple of years, as you'll see this morning with my colleagues a lot, we're seeing the device pattern show up. We can now have a little bit of GIS everywhere. I pull it out of my pocket and I can access the services and server environment anytime, anywhere, on any device. The fifth pattern, which is making GIS pervasive, is just opening up. It's actually changing everything. And that is the cloud web pattern, which brings our services together, allows us to integrate dynamically information and make all of that data available, if you choose, on any of these devices. So I would propose to introduce an idea to you that GIS is at a major turning point. And this is my best guess. 50 years ago, it was a limping along technology done by a few people who were interested in computational geography. Mainframes were the platform. When it moved to mini computers, a few thousand people, then workstations, a few tens of thousands, then PCs, a few hundreds of thousands. When the web hit, it went to a few million people accessing it. What I want to suggest to you is that GIS is about to grow several orders of magnitude more to virtually everyone. Not as a consumer application. I don't want to get ahead of the plot here. I'll simply say it starts off with this. GIS is advancing. It's leveraging and converging with a lot of other trends. GIS itself is becoming more powerful and easier, as you'll see in many of the demonstrations this morning. It's becoming more real-time. That's a big theme. Wiring up real-time measurement. It's becoming more 3D, as you'll see, not simply 3D visualization, but 3D analysis, as you'll see. It's becoming more analytic with new tools for integration of statistics and other things. And at the same time, more measurement. And that means more data, big data. I'm talking about really big data. And the computing platform that we're living on is taking a huge leap. We're moving from PCs and servers into the cloud and with devices so that we can access all of that information anytime, anywhere, by anyone. And this will happen with apps, not the traditional applications that we've had to build, but with free, downloadable, configurable apps that open up and provide the magic of that GIS for a much broader audience. And that's all evolving at the same time science in general is evolving. This will allow us to reimagine GIS in cloud environments. It'll allow you to reimagine your own career. Your own career is going to be very strong because somebody needs to build and maintain this kind of infrastructure and provide access to continue building the geospatial foundation, which suddenly becomes leveraged by everyone else. This is the picture, and pay attention to this picture. It's a cloud platform that integrates and extends what we already know of as GIS, but provides access to that same information base by virtually everyone with a device or a browser, allows embedding of geospatial services into any app, any brand, any flavor, any application, and integrates in with the enterprise IT environments that organizations run with. This is kind of a front end for the back end of GIS. I mean, Google sometimes says about us, we're really great, and by the way, we really love Google too. They have front-end technology, and Esri has back-end technology, and these things can be wired together, as some of you have done. This, ladies and gentlemen, is the front end for our back end. It's the front office for the back office that lives in a distributed environment. And it goes into every office. Well, what does that mean? It means I can plug in my desktop and server technology into a cloud environment and allow it to become available with pervasive devices. These little iPhones, iPads, Android devices, Windows devices, etc., browsers. It kind of opens it up if you want it to be opened up. It changes the user experience from the traditional desktop environment, which many of you live in, buttons, legends, and so on, and moves it in a direction that allows people to have wide open access, like this little app here for the mayor of Boston, 3 little green buttons. Today it shows them 3 indicators are doing okay, but 1 is doing not okay. It shows them where it's moving over time. Is crime getting better? Are the water mains getting better? Are the street repairs going in the right direction today? And whatever your enterprise and activity is, ocean monitoring, conservation, police, military, people are interested in this. Executives are interested in, is the arrow going in the right direction, geospatially? And so this new environment that I'm talking about is all about that, and also providing it pervasively, so I don't have to go to the White House's situation awareness room to see what's going on. I see it. It isn't just a few. You will be opening up understanding for the planet through this kind of device. It's no different than how music got opened up through the iPhone and iMusic. Boom. It became available to everyone anytime. And that's what I think the big shift is. And by the way, it means that we can bring any kind of information into it. These things we call web maps are a new language. They allow us to plug in remote sensing data, imagery data, sensor networks, Twitter feeds, social media, maps, big data, any kind of data, spreadsheets, into a cloud environment integratable through web maps, and then publish out these web maps. These web maps are a specification, of course. They're not just a map. They're that simple to use slippy map environment like we've gotten used to with consumer mapping that point at distributed services. So a web map might be a mashup of 3 or 4 other services, and the web map is published and usable by any device and embeddable in websites and in social media and emailable. And these services are real time, so as the traffic changes, my web map changes. As the water changes, as anything changes, my data is always up to date. This specification, this new medium, changes the discussion. It used to be this diagram on the right. I mean, I've drawn it probably 40 years now in different technology formats. It used to be a database can in the center. Put everything into one database, and then everybody can use it and share it. But that was tough because everybody had to agree to a common data model. And that's not such a bad idea, except that it's hard to get people to agree. What do you mean, I don't want to agree to your data model. I like my own better. You know that story? So this new cloud web environment represents a new enabling platform that changes the discussion. And we will see this morning in the city of Wellington, but also in Hamilton. Also, I have literally hundreds and hundreds of organizations around the planet that in the last few weeks have moved into this environment, and everything changes. The whole discussion changes. People start collaborating much more. They break down the barriers much more because there's no obstacle to collaboration. These are some of the organizations that are doing it. The UN is doing it. The European Eye on Earth organization is doing it. In my government, USGS, EPA, the Census Bureau, they're all putting data into the cloud and skinning, building a user interface for the cloud, which is for their agency. And when they put the data in, it's able to be mashed up and combined, almost as if it's in one database. And there are now hundreds of organizations doing this. Last week, we saw several hundred million maps made on one day in this environment by many different agencies that are collaborating, and it's only been out about 11 weeks. So this, to me, is interesting. It's a new pattern. And this cloud GIS is going to open up our world. It's going to allow us to connect people. It's going to allow us to enable many more people into that space. So let me bottom line it for you as practitioners. The technology is now starting to be used. It's actually matured enough to use it. People are beginning to embrace this pattern, but we have to learn how to use this new pattern, because in some ways it's much easier than what we've been dealing with before. We still need the back office for the front office, but this front office is accelerating. So in these first 12 weeks, since its release, every week we're going up millions and millions of maps that are being used, but also hundreds of thousands of maps that are being shared in common. So it requires a different kind of culture, like the culture of sharing. And that's a little awkward because my agency doesn't share. You know, that's my data. Yeah, that's true. I mean, there's many kinds of data that should not be shared for privacy reasons or IP reasons. But there's also a lot of public data that should be shared. Public data is, as a matter of fact, at least it's my belief that public data should be public. That's a bit of a political statement, but not always. I mean, and I realize I'm from a weird country that can't agree on anything these days. But this is something that I believe in quite passionately, that scientific information should be shared and available for use and integration and evolution. So I believe in this quite strongly, as you'll see as the morning progresses, because at this stage in the technology, I think we're onto something that's going to change our field. So I'd like to switch the topic just for a couple minutes and drill into the specifics of what we've been working on, because I know some of you will find that interesting. With ArcGIS, ArcGIS 10.1 is a big step forward. How many of you actually have downloaded it and are deployed with it? About 22%. Pretty good. That's good. It makes GIS or ArcGIS easier and more functional. It has lots of new capabilities, one might say, and also it includes this cloud capability, which I'll come back to in a couple minutes. So in some ways, 10.1 is just another release on the progress of what we've been working on for many years. It's got a lot of that improvement stuff in quality and functionality. But at the same time, it has this other architecture integrated into it, which is the cloud web architecture. And I'll close with that, with a little bit of that. But if you look at this diagram, it shows there's desktops in ArcGIS. There's servers in ArcGIS. There's a bunch of free apps that run on devices and web environments that are part of the system. And there's also an online or a cloud part of the system, but it's one system. Just like when I buy an iPhone, I connect into the iCloud and I can get music and I can do email and like that. It's not separate from the rest of the whole ecosystem. Thus, same philosophy here. And the world in the center is representing content. Some content is private content, some content is shared content, some content is commercial content, but content at 10.1 becomes a major and significant piece of the product. So to put this in perspective, we spend about $170 million a year on development for this system. And also an additional roughly 25 million on content a year. This is free to users, and let's look at it for a moment. In the last couple of years, we've been building base maps for the whole world. A topographic base map, a new base map from National Geographic Society, a beautiful ocean base map. Many of these maps are made with collaboration from you, particularly the ocean base map here in New Zealand, and the topographic map is just spectacular because of community contribution. We bring it in, we use a common template, and then we publish it out as free web services. The little diagram on the right shows last year, this year, and the end of this year imagery coverage. So we have spent tens of millions of dollars buying all of the satellite imagery from GOI initially, and this year Digital Globe, to provide a continuous tiled mosaic at multiple scales for the entire planet. That's what I mean by this notion that if you have a desktop, you buy a little ArcView, suddenly you have millions of dollars of content that are behind it. And that's continuing. At 10.1, we've made it a better desktop by improving editing and cartography experiences, dynamic legends, map generalization, lots of cool tools for those of you in the map making and editing business. We've also expanded 3D. It's much faster performance of 3D. There's more analytic tools in 3D using a full 3D data model. Also, there is, as of a couple weeks ago, a new 3D editor as part of City Engine, which allows you to do things like on the right, designing buildings or doing 3D extraction of features from your 2D data. It's kind of like SketchUp, but it's in some ways much richer because it's a database behind it, but it's also less sophisticated in the architectural design area. This automatic rules-based City Engine technology, explore that, it's kind of fun. 10.1 also unlocks LiDAR. It supports the direct reading of LAS files, so you can analyze and visualize LiDAR data. 10.1 fully integrates image processing tools, so instead of having a standalone image processing platform and GIS, this is actually an integrated system. So it has all the standard orthophoto creation, mosaicing, classification tools, and little ArcView. So ArcView suddenly is an image management platform. This platform is extended, however, with our partners like Envy, who have a wonderful platform for high-end multispectral imagery. So it's not only us doing it, we also have partners that extend it and build some beautiful things. On the server side, some of you know that ArcGIS Server is an image server platform, very scalable for millions of images actually in near real time. Very fast, and I invite those of you interested in imagery to look at it, because this is a big step in our history. A lot of resources spent on this one. Next, 10.1 connects the desktop with the server and the cloud. If I make a nice map on my desktop, I make it an ARC map, I can right-click, send it over to the server, and it automatically turns it into a service. So that was difficult to do prior to 10.1. This has simplified it. And if I don't have a server and I don't want to get a server, I can do the same thing and send it over to the cloud and have it stand up a map service for my users or for myself. There's a lot of improvements speaking about server. It's faster. It's actually, if there's one story I want to emphasize about server, about 10.1, it is that we almost completely rewrote server. We did this so that it's enterprise ready, very scalable, 64-bit, highly scalable, running on not just Windows now, but also just as well on Linux. And then a lot of detail things like web printing, a better user interface, new open APIs and standards supports, and then a lot of apps. On top of the server, and this relates to both ArcGIS Server and online, is a whole new class of what we call apps. And I want you to pay attention to this. Apps are free. They're all kinds of viewer apps, and we have a large engineering team that's working on these apps. These are easily configured apps. So instead of you writing your own Flex or JavaScript app, you can download an app and configure it. And also the SDKs are traveling with them. In the web world, in the desktop world, and also in the mobile space. These mobile apps are running on all the popular devices, and they run both in HTML5, if you want to write once and spread everywhere, but also there are apps for the mobile devices that are native for each app. And if you configure an app on one device, it'll actually run across the different devices even though the app is differently. And there's lots of good functionality here, editing and viewing, things like crowdsourcing I might want to use in my community to get what the neighborhoods are saying. That's all built into these mobile apps. And these are all, again, downloadable from the Resource Center for free. They just work with the server or the online environment. How many of you here would call yourself a developer? Not a lot, but for us, developers are very important because they make apps come alive. We've spent a lot of time at 10.1 ensuring that we have strong developer environments, and this is an area we're going to be pouring more resources into in the future, particularly the lightweight web app and mobile app environments. All platforms, strong open APIs for the developer community. Okay, now lastly, the 10.1 has transformational ingredients. So I've talked mostly about feature function up to this point. Now I want to shift gears and go back to this cloud story. ArcGIS is at a major turning point, and I'll say it this way. It's becoming not simply a platform for your department or your workflows. It's becoming a platform for the entire organization. And that's different. And ArcGIS Online, this cloud environment, provides that glue that links together what you're doing to everyone else in the organization. The diagram does a pretty good job of it. It says GIS professionals can share inside their organization, not for the outside, inside their organization, their knowledge, models, maps, data, services, and make it available to others inside their organization with an on-premise or a carefully articulated open cloud implementation. To executives, in this case, Department of Interior in my country, have brought all the scientific data in the National Parks Department, Forest Service, Water Department, all the various agencies, so that the Secretary of Interior can now brief the President with information about all the bureaus. This is different. Same inside of the military and intel organizations. There's some very sophisticated people like yourself that are building the knowledge, but this is like inventing a printing press on the web for not only sharing it, but also the ability to combine it, to run analytics, to contribute information into it. Also, a system for content management, bringing all of the data that is distributed in an organization together and providing this easy-to-use access. And this is open. So, of course, our systems can plug into it. That's by design. But also, any server can plug into it. And also, there's open APIs so that anyone interested in open source application development on top of this platform can do that and exploit it. The notion is that ArcGIS Online can integrate existing ArcGIS infrastructure, distributed servers, distributed desktops, distributed data sets, catalog them, allow any app or client to search that catalog, find the data that they want, mash it up, overlay it, and store the mashup so that other people can search the catalog and find that piece of integrative work. Today, this is all about visualization, and that's pretty strong, and simple analytics. But over time, you will see increasingly richer analytics put in that hosted environment where models can be running dynamically and accessible, even though I'm having a new kind of user experience to that modeling environment. You guys following me on this? Somewhat? Little bit? Okay, I agree. It's kind of complicated when you first get it. Along the top here is ArcGIS Online. It has a skin. You can go there right now if you want to look at it. It has 780,000 maps in there that people have shared, and there's about 100 million maps a day being used. And you can divide these maps into groups. So groups that you can share data with, or no, I don't want to share my data, like a big oil company doesn't want to share their data with anybody, or a conservation group may not want to share it. On the other hand, some data can be shared. But you'll notice the second tier, our US EPA has reskinned the face of that ArcGIS Online for their community and users. And they have their own content, and they have their own groups, and they have their own maps. And the state of Utah has done the same thing, and now there are about 1,000 organizations that have, just in this first couple of months, done that. And they're sharing their data not only within their own organization, but also some of the data gets shared beyond. So rather than me talk about it, it's better actually for me to introduce my colleague, Bernie Zukowski, and he's going to actually demonstrate it. Bernie.
Thank you. We introduced ArcGIS Online about 4 years ago, and since then it's evolved quite a lot. It's evolved from a simple framework for sharing into an integral and integrated cloud component of the ArcGIS system. Now, about 12 weeks ago, we released some new capabilities for organizations. And after that release, we had many early adopters across the globe. And we've invited one of those early adopters, Hamilton City Council, to join us on stage here today. Now, I've learned a lot from this organization and the gentleman that I'm about to introduce. What I've learned is that the real power of ArcGIS Online isn't so much the features and the functions that it provides, but rather it's the way that it can transform the way an organization works and add efficiency. It's my pleasure now to introduce Hamilton's Information Manager, Mr. Chris Marden. Chris.
Over the last couple of years, Hamilton has faced the usual sorts of challenges. Okay, so we've had efficiency targets and resource limitations on one hand, we've had service expectations on the other. Now, in the GIS space in particular, having recently migrated our legacy systems across to the Esri tools, we have had some reasonably high expectations to show some progress, whereas in the back office, however, we have been reduced down to pretty much one GIS specialist. So that's pretty thin for an organisation of our size. What we really needed was a way that we could start doing more with less. And you know, doing more with less, that's easy to say, but how do you do that? And what do you actually need to start making that a reality within your organisation? Well, we're on the beginning of that journey, but for us it really comes down to two considerations. And for us that really is about self-service and it's about recycling. So when I talk about recycling, as you'll see shortly when I demonstrate our externally facing web maps through ArcGIS Online, the approach behind ArcGIS Online allows you to develop a number of templates, and then using those templates you can create a whole bunch of web maps by simply reusing those templates and consuming new information into them. When I talk about self-service, by giving users the ability to service their own needs, we aim to reduce the reliance on IS and increase the capability within the organisation by leveraging the power of our users. So we're already sort of using the self-service model in our data area, where our data guys traditionally used to just deliver static reports to internal customers. What they're doing now is they're beginning to develop 3D cubes and data models, and then train our users to be able to develop their own reporting needs from those technologies. If you now take the offering that ArcGIS Online has and overlay that with what we're already doing, now you can start to see the potential for our users to be able to create, let's say, Excel spreadsheets from corporate data, and then be able to use some tools like Esri Maps for Office to then be able to create their own intelligent web maps from that data. So you're going to see that in a demonstration a little later on. With such a small GIS team within Hamilton in the IS department, we see self-service as a way to empower the business and to make GIS type functions more accessible. To do this, of course, the reality is that you need a robust technology and you need something that's very easy and quick to deploy and train users on. And so that demo will be coming up a little later on. So let's have a look at ArcGIS Online. Here, hopefully what you can see is the web map, some of the web maps that we've created, and I'm going to come in here and this is our property page. So the concept behind ArcGIS Online, as I've said, is that the single monolithic viewer is being replaced by smaller targeted viewers that only contain the information that's relevant for your users, and because each viewer is a separate application hosted in the cloud with a separate URL, you can distribute them across your website. So I've got a viewer actually accessible from our property page here. So here we see the template, and across the top we've got the functions, layers, and search functions in print. Turn on our photography. So by typing in an address, we can zoom to that location. For some reason I can't see it on my screen, but you hopefully will be able to. And you can click on, there we go. You can click on a property of interest, and what you're presented with is a summary of your property information that then contains a hyperlink that then takes you back to our website where you can access further property information and all the rating information that we need for that property. So as you can see, by sort of condensing that information down and only displaying what you need for your users at that point, you're not sort of giving people more information than they need or more information than they want. From a cost perspective also, having this templatable approach to our corporate external mapping minimizes the development work that we need to do, and we can create multiple viewers by taking these templates and recycling them for use with different data.
So thank you, Chris. That was an excellent presentation. We learned a lot from Chris, and Chris mentioned some very important things. Extending the reach of his GIS out to a broader audience, making choices which make sense economically, increasing his efficiencies. These are all the things that ArcGIS Online can enable us to do. Now, Chris has been kind enough to enable myself and others, my colleagues here at Eagle, access to their organization. And we've been working behind the scenes, and we've been able to take a look at a few things, and let's just take a look at a few of those now. So I am an organization administrator, and behind the scenes what I can do is administer my organization. These are members of my organization, and I can assign them different roles. They can be administrators, they can be users, they can be publishers. I can also manage all the content of my organization, and I can organize it into groups. And what's very interesting about this is that organizations tend to organize these groups and build those into the patterns that exist, the workflows, how they work, how they operate. So many of the groups that we typically see in organizations reflect projects, or they reflect components of the organization. So ArcGIS Online maps to your organization naturally. So this is a wonderful site that Chris and Hamilton have created, and we're going to be using this for some of the demonstrations that are about to ensue. It's a powerful portal for extending the reach of your geospatial information, and it's also very powerful, as Chris noted, for enabling self-service mapping. So to learn a little bit more about that, it's my pleasure now to introduce my colleague from Eagle, Trish Mertz.
Thanks, Bern. As a member of the building control team at Hamilton City Council, I'm responsible for the release and approval of building consents within the city. My boss has come to me and asked me to create a map comparing building consents approved in 2011 and 2012. Now, I know a good place to start is my Hamilton City Council ArcGIS Online account. There's an existing map showing building consents from 2011, so I'm going to search for that. I search for the web map, and immediately I'm able to find what I'm looking for. This is the same web map that I have open already in this tab. I'm going to start by changing the symbols. I'm going to use a color, and I'm going to use this color to show a total column. This is the total number of building consents that have been approved in 2011. Now, I'd like to choose this green color ramp, and I'll apply the symbology. Immediately, we can see there are neighborhoods in the northeast of the city that have had a larger number of building consents approved in 2011. Perhaps there are some new suburbs that are being constructed there. Now I'm ready to get on to mapping my 2012 data. Now this data has been provided to me in a text file. Let's open it up and have a look. Wow. I don't really have time to format this data, so what I'm going to do is I'm just going to grab it, drag it, and drop it onto my map. Let's see what happens. Wow, that's just saved me a lot of time. If I click on one of these points, I can also see that my attributes have been carried across as well. This is great. Now what I'd like to do is customize this pop-up window to be able to tell my story a bit better. So what I'll do is I'll choose to configure a pop-up, and now I can format it to tell my story better. Pop-ups support rich content such as HTML and images, and I have a field in here that depicts the type of building consent. So I'm going to choose that image field. Next, I'd like to choose certain attributes that I'd like to display within my pop-up. In this case, I'd like to choose the estimated cost, the suburb that building consent was approved in, as well as a link. This is a link that directs users back to the original building consent report. Lastly, I'll choose an appropriate title. I'll save my pop-up, and now we can see I get a more customized view of the information contained within my file. If I click on the hyperlink, I'm then taken to that building consent report. Now, pop-ups also support simple graphs and charts. So if I click to my area unit displayed below, I can see my building consents are being displayed to me by the building consent type. In this particular suburb, we can see more repairs happened than new construction work. Now I'm ready to share my map. I have a few options available to me that allow me to leverage the same web map and a few different options. We can, for example, make a web application. And ArcGIS Online comes available with several out-of-the-box, ready-to-go web map applications. First, what I'm going to do is I'm going to save my map. All of those changes haven't yet been committed. So once I save my map and reopen that mapping application, we'll just refresh it, we'll see all of those changes that we've made on that base web map. There we go. So we can see we've got an application with some basic functionality. For example, I can choose the base map, measure, or print this as well. Now, I'm actually interested in providing this web map to my web administrator, because we're going to embed this in our existing website. To do that, I'm going to choose to share this, and I'll choose Embed in Website. Now, all I need to do is copy and paste this HTML and provide it to my web administrator, who can then use this to embed it in our existing website. Let's have a look at what this looks like. Here, I'm on my Build Hamilton website, and if I scroll down, I can see that same web map that I just showed you with all the rich pop-up maps and charts that I've just created in ArcGIS Online, but available to me on my organization's website. So let's take a step back and think about what just happened. In a matter of minutes, I was able to create a rich web map with a customized view of my organizational information and share that with my web administrator on my organization's website. And with that, I'll hand it back to you, Bern.
Thanks, Trish. Now, Trish showed some very powerful capabilities. Remember that messy text file of data that she had? She was able to turn that quickly and easily into more meaningful information in the context of a map. And she was also able to take that map and use it in many different ways. She first configured it, very easily done, no programming required, and then she was able to save that map and show its use in different templates, and also to be able to embed that into a website. So this is pretty powerful stuff. And this is all enabled by what Jack talked about earlier. This is a web map, and a web map at Esri is more than just a map in a browser. It's actually a technical specification that enables their use across many different applications and across many different devices, and also embeddable capabilities as well as the ability to use them in some templates. Now earlier, Jack talked about storytelling with maps, and this is that website. It's storymaps.esri.com, and you'll find many interesting examples that you can visit and review and use. Another interesting part of this website is I can choose to view maps, story maps by the Esri community, and what you'll notice here are that there are a few that represent the fine GIS community of New Zealand. So here's a solar radiation viewer. It's an application that was built using one of the story map templates by the city of Wellington. So this is pretty amazing. It's very powerful. So you can quickly and easily configure a web map and use it in templates like this. And in fact, the Hamilton City Council has also used one of these to build a story map about Hamilton City Parks. Author your web map, download the template, insert your map, and begin telling your story. So it's a very powerful way to begin presenting your information to a much broader audience. So now everybody knows how to do this, so we expect to see much more. So we've solved one of the big challenges as GIS professionals. But there are other challenges that we face. How do we take the data that's locked into our ArcGIS for desktops and make that more readily available? Well, as it turns out, ArcGIS Online offers some compelling capabilities which make that easy. And now I'd like to turn it back to Trish to show us how that works.
A stormwater main in the Hamilton CBD has burst and requires urgent repair work. The asset management team lead comes to me, the GIS analyst at Hamilton City Council, and requests a map of all stormwater assets be made available immediately to mobile field crew. In the past, this workflow would have involved me packaging up my data, sending it to my web administrator, who would then make my content available. If my web administrator was busy or had left early, then this workflow would just have to wait. Many of my fellow GIS analysts in the audience would probably agree, we're lucky to even get our content published at all. Let me take you through a scenario in ArcGIS 10.1 that will show you how this workflow is changing. So I'll start in desktop, where I already have a map depicting the city's stormwater assets. Previously, I'd probably resort to printing this map as a PDF and giving that to my field crew. But now, all I have to do is sign into ArcGIS Online, and all of my content can be made available to others within my organization. Now, this is the same ArcGIS Online for Organizations account that I was accessing previously in the browser, but now I'm accessing it here directly in desktop. So before I'm ready to share my services to my online account, I need to remove my base map, because I'm only interested in sharing my operational data. Now, I'll choose to share my map as a service, and I'll choose my hosted services account. This is my Hamilton City Council ArcGIS Online for Organizations account. Continuing through the wizard, I can choose the capabilities that I'd like to enable on my service. In this case, I'll enable feature access, because I want to give the field crew the ability to update the data as needed while they're in the field. Moving over to my item description tab, I can see that all of the description information I've saved in my map document has been transferred over to my service. And this is going to be pushed up to the cloud along with my data. Finally, I'll choose to share this with members of my organization. In this case, I'm going to choose the Hamilton City Council Asset Management Team, because this is the team that needs to be able to access my content quickly. By sharing it with this group, all they need to do is go to the Group tab, and they don't have to search for the content themselves. It will just be made available to them. Now I'm ready to publish my service. What's happening is my data is being packaged up in a service definition file that will then be pushed to the cloud, where it will be made available to me as a service. Let's move over to my organizational account. I'll go to my Groups tab, and we'll go to that same asset management group that I've shared this service with. Now my service is still publishing. It's finished, and now if I go back to my Groups tab and refresh the view, we'll see that new service has been made available to me. The next step is to open this up in a web map, and I've already got one open here. So we can see this is the same service, the same data that I was working with, in desktop, but available to me in ArcGIS Online. Now, the asset management team lead has told me that a particular water main is in need of service. So before I finish with my map, I'm going to choose that service main, and I'm going to change the service status to service needed. This is going to let my field crew know that this is a particular stormwater main that is in need of some attention. I'm also going to draw a map note around this area, and I'll enter some descriptive text about what the problem is. Great. Now, I'll save my map, and the same web map will be made available to my field crew on their mobile devices. Let's walk over to my mobile device, and I'll give you a view of what that looks like. So when I come over to my web map, same web map that I showed you in my ArcGIS Online for Organizations account, I can see the same information that I've been working with. The field crew can then edit the data when they're in the field. Once they've made the required changes, they can then change the service status from service needed to live. This will let the rest of us know that the required repairs have been made. So let's have a think about what just happened. In a matter of minutes, I was able to push my content from desktop to the cloud, author it in a web map, and have that same web map available to field crews on their mobile devices. This is really going to transform the way we, as GIS professionals, operate. With that, I'll hand it back to you, Bern.
Thanks, Trish. Pretty powerful, desktop to the cloud to the field. Pretty amazing. But that's not all. ArcGIS Online can empower other parts of your organization. It can go into the far corners of your organization's offices. And that's accomplished through something new called Esri Maps for Office. I can't think of anybody better than the person I'm about to introduce to show you how this works. Please welcome Nate Bennett.
Thanks, Bernie. So imagine I'm a spreadsheet user. Here's a spreadsheet of food premises monitored by HCC. So where are these businesses located? It's pretty hard to tell looking at all this information in rows and columns. Now we know a map is a much better way to answer questions like this. So what are our options? Well, Trish just showed how we can map a spreadsheet in the browser. That's a good option. And of course, there's always ArcGIS for desktop. ArcMap, after all, is the best mapping tool out there for GIS users. But what about everyone else? There should be an easier way. In an ideal world, someone could map their spreadsheets right inside Excel. This is Esri Maps for Office, a new ribbon group added to Excel full of tools to help you map your spreadsheets. Imagine if you could put a focused mapping tool like this in the hands of all your Excel users. Well, now you can, because this is part of ArcGIS Online. Let me show you just how easy it is to map your spreadsheets in Excel. Here's another view of some HCC data, this time showing noise complaints. Now in Excel, adding a map is as easy as adding a chart. Now you can take advantage of the addresses, the coordinates, and the well-known places that already exist in your data. So here we're going to be adding around 5,000 noise complaints. And these complaints are being visualized with a technique we call clustering. Clustering is a really smart way to work with dense data. Complaints close together are snapped and represented with a single symbol. Heat maps are also great for dense data and can be added right from the ribbon. It's really that easy to map your spreadsheets in Excel, but this is an Esri map. We can do more. Seeing the individual location of complaints is helpful for understanding where reports are being filed, but how do they vary across the city? Well, we can use Excel to aggregate this data in a pivot table. Now you can join your data to common geographies out of the box, but you can also add your own locations, your own custom geographies, like in this case, Hamilton area units. And once the area units are added to the map, they can be symbolized with a single color or with a color ramp. So now we can see areas that have high concentration of noise complaints like surprise around the university. So there's a lot of great HCC data already shared on ArcGIS Online, and Excel users have access to all of it. So I can search in the HCC organization for schools. There's a school map service, and we can add it to the map. Now, in just a few moments, we've created a really interesting map. And because Excel is now a client to the ArcGIS Online system, this map can be shared as hosted services and then published throughout the organization with any specific groups. Now, we can also share this map in PowerPoint. So here we have PowerPoint on the left and Excel on the right. Now, like spreadsheets, most presentations can really benefit from the perspective a map provides. Now in Excel, on the Esri Maps ribbon, there's a Create Slide button. With a single click, maps embedded in our existing presentations. Now, PowerPoint also has its own Esri Maps ribbon, and it allows users to create slides of any map shared in their organization. So again, we can search in the HCC org for a noise complaint map that's already been published. And we can preview this map, we can configure the layers, and then we can also add a legend that'll provide some context for our end users. And we can create another map slide. So let's take a look at our finished presentation. This is a presentation about noise complaints in Hamilton. We've got a couple of graphs and a few maps that show noise complaints around the university. And finally, we have noise complaints by unit areas. But do you notice the play button on this map? It makes this map very special. With a single click, this map is transformed from a static image to a live interactive map. Now we can explore all 5,000 noise complaints in Hamilton right from our running PowerPoint presentation. This is Esri Maps for Office. Bernie?
Probably like most of you in this room, I live in a map-centric world, so when I think about things, I think of a map first. But we know that there's many more people in your organization that probably start with a spreadsheet, and this enables them to participate in this ecosystem. So, very powerful technology that enables you to extend the reach into other parts of your organization. Now, everything we've shown you so far represents out-of-the-box capabilities, but ArcGIS Online also has an API which lets us build custom applications like this one I have here in my iPad. So this is built using the iOS SDK, and this application lets us connect to one of the groups in the city of Hamilton and provides this nice page-turning experience which lets me explore the maps that Hamilton has created. When I find one of the maps that I'd like to view, I can click it, and I can view it and interact with it. And what's really important about this is devices like you see here, this iPad and tablets, these are the devices of choice for many executives and decision makers. And using ArcGIS Online and delivering it in applications like this, we can empower those that need it most, the executives and the managers that can benefit from our authoritative geographic knowledge. So with that, I'd like to thank Chris once again and HCC for enabling us to use their site for this demonstration, and I'd like to turn the stage back to Chris.
That stuff is really amazing, and in Hamilton we're really looking forward to the next step, which is, as I said, we're sort of at the beginning of our journey. We really want to take this self-service thing to the next level and start pushing some of this Esri Maps for Office to our users, create more web maps, and then get into some of the mobility stuff. So I think you'll all agree this is really sort of organisation-changing technology, and I really appreciate the work that Jack and his team have put into helping us develop some of this stuff. So
He's the one, really. Thank you, Chris.
you're welcome.
Thank you very, very
Okay.
much.
Cheers.
It's good.
All right.
Beautiful.
Okay, thanks.
It's good. Chris was a little courageous. He took a step out. He's scared, actually, to death back there. But interesting. What we're trying to get across in this demonstration is the notion that we can move beyond traditional GIS-focused areas. In other words, provide a platform that transforms an entire organization. And we've seen this through the feature function demonstrations, a little of this, a little of that, again and again. That's kind of the vision that we're pushing for. We showed it not only with the base viewer technology, but also with its integration with Microsoft's Office and PowerPoint and email, the idea that the 890 million Office users can now make maps with their spreadsheets. That's a pretty cool idea. It spatializes vast other areas of the IT organizations. It also supports something that's emerging. This is a new idea for you. We call it location analytics. This is not simply geospatially enabling Office, but also SharePoint. So the same ArcGIS content platform that's transactionally growing, has global geocoding, has wonderful images and maps, can also be integrated totally with SharePoint, a kind of cross-cutting collaboration environment. That same environment can also be integrated with IBM's business intelligence platform, Cognos, so that data mining not only is supported through lists and charts and graphs, but also through maps, same kind of environment of drag and drop that Bernie and others showed a moment ago. And that's only the beginning. We intend to support things like MicroStrategy, SAP, other sorts of BI environments. And while Microsoft and IBM are the leaders in their respective areas, our hope is that we can spatially enable the IT organizations, the real back office, that provide the real front office for the entire organization. And this isn't just about making little dots on maps. Over time, it'll involve the integration of all of your information as a kind of into a kind of delivery mechanism that reaches out across the entire organization. So cloud means much more than open cloud. It really means a new kind of architecture, a cloud architecture that can cluster knowledge and provide it to everyone. What's coming next this year, next year? These are a kind of list that'll give you some notion of it. First off, in March, we will release a version of ArcGIS that is called Service Pack 2, or sometimes we refer to it as 10.1.2. It'll have full 64-bit geoprocessing capability in the desktop. And then next year, sometime at the end of the year, we'll have full 64-bit processing for the entire desktop, but that's a separate development effort. We'll also have increasingly online geoprocessing. I mentioned that a couple of times before, that ArcGIS Online is very much map visualization, query, the kind of language of maps focused today, but ultimately it'll have polygon processing and analytics that are built into it. A very small thing, but really not so small, is that those little mobile apps that you're going to be seeing some more demonstrations of in a moment will, in the spring, the March release, be disconnectable. So I can be connected to your server or to the online environment with maps. I can disconnect it, do some updating, reconnect, and they resynchronize. This is obviously an application for the military kind of user, but also for the forester, but also for the guy who's repairing streets, and also the utility expert, and also actually everyone. So this doesn't actually exist, this notion of disconnected editing in consumer kind of mapping environments for I don't know what reason, but it's key to making the field workers part of the enterprise connection. And then there'll be more 3D work. We'll see some of that on stage in a minute. And then longer term, well, you can look at the list. Lots of interesting things. As I mentioned, we spend a couple $100 million a year of your money. That's a big responsibility, and we take that seriously. We keep trying to push the edge, and that's basically our goal, is to serve you. I'll close basically with this. Our job, as we see it, is advancing your platform and serving you, creating spatial literacy. That's part of it. A business report is that we are strong and growing. We are, as most of you know, a private company. We chose that by design. We are not leveraged. We're strong. This year we'll grow about 10% again, which is difficult in a recession year. And our goal is also, at least the way we make it up as my colleagues and I, is to make a difference with what we're doing. And in that sense, it's very important that our relationship is intact, that you tell us when we're screwing up. And we do it, more than I'd like to admit. But good friendship is about telling us when we are not doing so well, and then helping us figure out how to work around it. So I appreciate our relationship a lot. I appreciate the opportunity to be with you. We also have a number of programs that we think give back to society, and here again our community has been strong in our partnership. Is it next week, I think, or a week after is GIS Day. This is a time where we especially pay attention to putting GIS into schools. Esri has a program of donating our software to all the K-12 schools around the world, and there are tens of thousands of them. But the software doesn't do much good without a teacher or a mentor. So I invite you to be a geo-mentor. Ourselves, the U.S. National Geographic Society, and others support a program where we work through you and with you to adopt a teacher and adopt kids. We also are very strong in supporting NGOs around the world, especially in conservation, volunteer people who take on a responsibility to get involved in conserving nature, and we think of this as also part of our DNA. Our DNA also includes all nonprofits, as a matter of fact. We have tens of thousands of them around the world who we, again, provide training and software to grow up the informal community with geospatial information and technology and like sorts of activities. Well, I've talked a lot about a lot of things. I want to say thank you personally. I'm going to meet with a lot of you I know during these next couple of days. And again, let me conclude by saying I very much appreciate your work. I mean, it is a thrill to be with you for me. And we are not yet done for this morning. My colleague Bernie Zukowski is going to come and show you some of the other aspects besides ArcGIS Online in terms of the tools. Bernie, thank you.
Right before the break, we're going to cover one more section, and this section is about geo-enablement. So what does that really mean? It means enabling other people in your organization to use GIS, or it means enabling other people that may not even know what GIS is with GIS transparently, perhaps without them even knowing it. Earlier, you saw an example where Nate showed us how GIS can be used in the context of Esri Maps for Office, and that extends to other technologies like SharePoint. It also extends into other platforms like IBM Cognos for business intelligence. Here to tell us more about our activities there, I'd like to introduce our Director of Business Analytics, Mike Boriski. Mike.
In your roles, you expertly use Esri's ArcGIS platform, whether it's desktop, server, ArcGIS Online, and Esri's developer tools to directly benefit your organization's operations. But I'm here to tell you that there's another world of opportunity out there if you'd have even broader impact on your organizations. The opportunity before you is to add spatial to your CIO's other enterprise systems. Systems such as business intelligence, ERP, asset management, CRM, collaboration, and office productivity, to name a few. The market demand that we are seeing is to add spatial to your CIO's information analytics landscape. So why are your CIOs eagerly speaking with Esri? Because they are realizing that an enormous amount of their data that's pouring into their business systems is inherently spatial. Upwards of 80% according to some analysts. And that percentage is certain to grow even higher with the pervasiveness and ever-increasing quantities of mobile devices, sensors, and instrumentation that are producing geotagged data streams. Not to mention the location-aware information that's constantly being generated through social media outlets such as Twitter and Facebook. Companies are drowning in a sea of geographically aware data, yet the business systems that they're using simply aren't equipped to provide them with a geographic perspective. As a result, employees at all levels of the organization are making business decisions based on an incomplete picture. They're performing business analytics with a massive analytical gap. Esri is addressing this gap through the creation of a new portfolio of products called Location Analytics. So what is Location Analytics? It's the application of geography as a service to the enterprise systems, making those enterprise business systems better, more valuable to the business. A key aspect of Location Analytics products is the addition of complementary capabilities to the existing information systems. And not just dots at a map, but data visualization, such as thematic shading and heat maps, as well as spatial analytics, but geared to the business layperson. And these capabilities are done without any disruption to the existing information and user workflows. These products are a seamless extension of the business systems. And I'm happy to tell you that our users are reporting that the addition of Location Analytics is having a significant impact on their information analytics. It's adding tremendous value to the business. To illustrate this value, I'd like to introduce Jay, who will demonstrate one of our Location Analytics products, Esri Maps for SharePoint. Jay?
Many of you use SharePoint today for a number of different purposes. This could be for document collaboration or data management. But SharePoint offers a lot more. Esri Maps for SharePoint takes advantage of some of these features, like SharePoint workflows, allowing you to quickly and easily visualize your data. So let's have a look at a quick example of this. One of the councillors at Hamilton City Council has asked me to pull out a list of all the licensed premises that have liquor licenses associated with them in the Hamilton area. I was very quickly, I was able to go into our rating system and pull this out into a spreadsheet form. Now that I have this in the spreadsheet, my typical workflow is to take this document, upload it to SharePoint, and send someone the link and say, hey, here you go. But I know the next question coming to me is, can you make me a map of this? So there's a few ways we can do that. Nate touched on it using Esri Maps for Office to geo-enable the spreadsheet. The other way I can do it is actually make it a little bit more interactive. Instead of uploading the document to SharePoint, I'm actually going to import the document as a list into SharePoint. So very quickly, I use my standard SharePoint workflows to import the spreadsheet. I'm going to give it a name, browse to my spreadsheet, and hit import. This is going to take me very quickly back to my Excel environment, ask me what rows I want to import, and hit that import button. Once this is done, the import starts to begin, and you can see that it's adding the records into SharePoint. Now, this is taking the records from the spreadsheet and creating this into a list. Now, the one thing about the spreadsheet is, since I pulled it out of my rating system, I have the address data, but I have no X and Y location to put it on a map yet. But utilizing some of the workflow capability that Esri Maps for SharePoint offers, I'm able to do this. I'm able to kick off a workflow, in this case an ArcGIS geocoding workflow, that will allow me to geo-enable this list. A wizard style interface allows us to add XY values to this particular list. In this case, I'm going to use a locator from ArcGIS Online. I'm going to specify the fields that are available to me, the coordinates, whether I want those to be called X and Y, and the map options. And I'm going to kick off this workflow. Now this workflow is going to run in the background of SharePoint. Now this is great because it means I can continue to use my SharePoint environment and I'll get notified when this is complete. To save time, I've already done this. I've now created a page, and in that page, I've dropped in the Esri Maps for SharePoint web part. What I am then doing is I'm getting a base map from ArcGIS Online, and the data that you're seeing here is actually being driven off the list that's coming, that I uploaded that spreadsheet into. I've also used symbolization to categorize them by the different types of licenses. So red meaning clubs or bars, and the others meaning general premises. Like you've seen with all the other products, Esri Maps for SharePoint also gives you the ability to jump on and view things like pop-ups and other related information. If I open this particular item, I'm taken to the record now and given a map for that particular item. I'm also able to utilize the ribbon to carry out extra functions like change the base map, change certain layers, or modify the symbols. As you can see, the map is actually quite busy, so I can very quickly enable clustering to make that a little bit easier and simpler to view. For a more interesting view, I can add a heat map. Increase the intensity to show just where the majority of the liquor license permits are. And lastly, I can integrate Esri Maps for SharePoint back into my enterprise systems. If I have an ArcGIS for server environment, I can browse to that and bring in that data. In this particular example, I'm going to bring in suburbs around Hamilton and overlay that, so it gives me a great view of the liquor license premises with suburb information. That is Esri Maps for SharePoint. Back to you, Mike.
Now my colleague Nathan Bennett will demonstrate the benefits of another one of our location analytics products, Esri Maps for IBM Cognos. In this demonstration, we'll see how location analytics will significantly enhance the analytical capabilities of IBM Cognos Business Intelligence. Nathan?
Thanks, Mike. So here we're taking a look at a dashboard a national insurer would use to evaluate the current state of their book of business. So there's a list that's showing some district information with some key insurance policy metrics like total insured value, claims, net and gross loss, a pie chart of total insured value by different policy classes, and then a column chart of claims by districts. For an insurance company to be able to get an aggregate view of their business information through easy-to-use reports is incredibly valuable. Tables, charts, and graphs are great ways to visualize measure-based information. They completely ignore a critical component that exists in all business information: location. All business data has some sort of geographic dimension. And when you view that information on a map, patterns and trends that were once missed come alive and provide a whole different level of perspective. So here's that same dashboard with the perspective of a map. So here we're seeing total insured value by regions in New Zealand, and we can cycle through all the other measures right from the legend. Now we can also use this legend to very quickly focus in on particular segments, like in this case, our highest level classes of total insured value. And we're not able to just see the locations, but we have access to all the underlying attributes and measures which are available through pop-ups on the map. Now this map is actually tightly integrated with the underlying Cognos environment. So as we select features on the map, the associated data will be updated in the other tables, charts, and graphs. So let's imagine what it was like for an insurance company when the Christchurch earthquake hit. What's our exposure to risk? This is another very difficult question to answer without a map. But with Esri Maps for IBM Cognos, we empower BI users to be able to answer these tough questions. The first step is to drill into the Christchurch area. And right from the map, we can actually select an area like the Christchurch area and drill through from a national view to a more focused regional view of the policy information in the Christchurch area. So here's our regional report, and it's going to hydrate with just the policy information for the Christchurch area. So this report, we have the total insured value in millions, and then we have two charts on the left that are showing total insured value and gross loss across different policy classes, as well as across postal codes. And then we have our map. And on our map, we can see our individual customer locations, as well as this information aggregated to postal areas. So how could we begin to answer the earthquake question? Well, we can start by overlaying our business information with authoritative earthquake shake map data accessible from ArcGIS Online. This allows users to use very focused tools to pinpoint the exact exposure to risk. Using the layer filter tool, we can focus in on the shake map and select a particular level of intensity. In this case, we'll grab those with levels greater than 7.4, for instance. Using the tool, we can very easily select those areas on the map. And then with the layer filter tool, we can easily intersect that selection with all the underlying insurance information. And because the map is tightly integrated with the Cognos environment, all the other tables, charts, report items, and graphs update with that selected information. So with Esri Maps for IBM Cognos, we're empowering BI users to see their data in whole new ways and answer questions unlike they were ever able to before. Mike?
Thanks, Nathan. Clearly, the maps and spatial analytics made the BI dashboard better. Esri Maps for IBM Cognos made that dashboard more impactful, more insightful, and more valuable to the business. You name it, it was better. Esri is creating location analytics products to satisfy the burgeoning demands for spatial analytics across the organization. I encourage you to collaborate with your CIOs to identify opportunities to apply and benefit from location analytics within your organizations. Thank you.
Thank you, and welcome back from the break. So, this year has been a pretty amazing year for Esri, and Jack has highlighted some of the many features. The big event this year for us was the release of ArcGIS 10.1, and that's really an amazing platform. There's lots of new things that have happened at ArcGIS 10.1 that have taken many years, so it's years in the making, and it was delivered this year, which I think delivers to all of us some very exciting capabilities. Now, it's a major step forward for us. It brings together the cloud into the GIS platform and includes many interesting and compelling capabilities, which we will highlight here this morning. Now, ArcGIS's heart is ArcGIS for desktop, and that's been enhanced quite a bit. There's better editing tools, there's better data management tools, there's better tools that enable you to publish very quickly. You saw earlier today how you can publish maps directly from ArcGIS desktop to the cloud, and that's also possible using your own servers, which includes the ability to publish and share more widely geoprocessing tools. So to take us for a tour of these new capabilities, please welcome back Trish Mertz. Trish.
ArcGIS for Desktop is a powerful platform for the visualization, management, analysis, and dissemination of geospatial data. Now I'm going to take you on a tour of desktop and showcase some of the new tools and data models that allow us, the GIS professionals, to visualize, manage, analyze, and share our data in new and powerful ways. Our tour begins with visualization and the last data set, a new data model available at 10.1 that allows for the quick viewing and analysis of LiDAR data. So now at 10.1, we can quickly create a new last data set, browse to the location where our LiDAR is stored, and quickly be viewing this LiDAR directly in desktop. Now, I should mention that this LiDAR has been provided to us by TerraLink. This is their new terrestrial LiDAR. Now, by default, the LiDAR points are displayed by elevation value, but we can also view the LiDAR by return number or class code. Now, right within desktop, we can also view these points in a 3D window without having to switch over to ArcScene. So now we can see a more realistic view of the area that this LiDAR covers. Another window available to us in the new last data set toolbar is a profile window. This window allows us to select an area of interest and view that area in a side profile view. So if we zoom in here, we can see that we've got a tree that hasn't yet been classified. Using the tools in the profile view, I can select an area around the tree, and then I can change the class code In this case, I'm going to change it to medium vegetation. Now, I'm modifying the native LiDAR data on disk. Now, we can also view the new last data set in ArcScene as well. So what we're looking at here is that same LiDAR data, this time symbolized by RGB values. And this gives us a much better vision of reality. I'm going to zoom into an area here. And next, I'm going to add some 3D buildings. Another benefit of terrestrial LiDAR is the ability to use it to validate against our existing geospatial data. In this case, I'm going to bring up my 3D editor, start editing, and now I can select my 3D buildings and move them around so that they properly line up with this terrestrial LiDAR. Now, this new data set has allowed me to very quickly and easily browse to my LiDAR on disk and within seconds be viewing it and working with it directly in ArcMap and ArcScene. The next part of my tour takes us to the new data management capabilities available at 10.1. At 10.1, we can now enable something called editor tracking. The ability to automatically track edits helps us maintain accountability and allows us to enforce quality standards on our data. To enable editor tracking at 10.1, all we need to do is simply browse to the location where our data is stored, go into the feature class properties, and there we are able to enable editor tracking. Now I'm going to start an edit session on my data. And I'll show you how editor tracking works. I'm going to grab a new stormwater main. And first, I'm going to label this feature. And this is going to be labeled by my username and also the date. So this is the last editor and the date that this data was last edited. So now, when I start digitizing on the map and finish, we can see that my username and the date that data was last edited has been automatically added to the geodatabase. So this saved me a lot of time. I don't have to worry about tracking any of this information myself now. Next, I'm going to move on to the new spatial analytical capabilities of ArcGIS at 10.1. What we're viewing here is Nokia's NavTech traffic data. This data shows us traffic patterns, which has been averaged over a 365-day period. So I can use this data in order to predict traffic patterns across the city at various times of the day and at various days of the week. In this particular scenario, 2 high-end grocery store locations are interested in modeling accessibility patterns to their stores at various times of the day. They're interested in being able to know where their target market exists, and they're also interested in how accessible their stores are to this target market population. Now, I should mention that this target market data has been provided by Stats New Zealand. I simply went onto the Market Mapper website, entered in my target market parameters. In this case, my high-end grocery store chain is targeting those between 25 and 34-year-olds and those with a high income. So I've simply downloaded the data and joined it to my area units. Now, the next part of my analysis, I'm going to open up my model. So I've created a specific model that first generates some service area polygons, which I'll show you. and then runs a tool called tabulate intersection. So let me explain how this works. The first thing that I want to do is draw service area polygons around my two facilities. This will show me how accessible my stores are to people within certain drive times to these stores. Now, the next thing that I want to do is I want to actually cross-tabulate this with that target market data that I've just shown you and apportion the data so that I can see the total number of individuals that fall within my various drive times that fall within my target market population. And all of this is possible using a new tool called tabulate intersection that's available at 10.1. So that's really the key to this model. So what I'm going to do is I'll go back to that model and I'll run it. I'm going to run it at both of the stores, and I'm going to run it on a Sunday afternoon where I know people within my target market population tend to do their grocery shopping. So I'll choose my first facility, and I'll run the model. So let's think about what's happening here. First, we're deriving those service area polygons. These service area polygons are showing us the drive times to those target market populations. And the output of this model is a graph. So we can see that within a 0 to 5 minute drive time, we are accessible to 30% of our target market population. So this is good information. Now, I'm going to rerun the model. This time, I'm going to run it on my second facility. And let's compare accessibility to that first store to my second store. So we can see that within that first drive time ring of 0 to 5 minutes, I'm not reaching as large of a target market. So this is really useful information that I can use to derive product promotions, staffing, and other operational decisions at my various facilities. Now, I mentioned that ArcGIS 10.1 also allows us to be able to share our data in a new way. At ArcGIS 10.1, there's a new workflow for sharing your geoprocessing services. I'm going to show you how this is possible. I'm going to open up my results panel, and this shows the results of those models that I've just run. I can right-click on one of those models, results, choose to share it as a service, and now we see that same wizard that we'd been looking at earlier today. But this one allows me to share my geoprocessing service. And you walk through the same steps that we were looking at previously. In this case, I'm going to choose my local ArcGIS server. I'll choose where I want that service to be located, and then I'll go through similar parameters that I showed you earlier today. I'm going to stop here, though, because we're going to see the same model shown in different ways in the presentations that are to come. So I hope you've enjoyed my tour of desktop, and I've given you a little bit of a taste about what's to come in ArcGIS 10.1 that allow us GIS professionals to visualize, edit, analyze, and disseminate our information in these new and powerful ways.
Thanks, Trish. So we saw visualization, we saw data management, we saw sharing, we saw publishing to the cloud, and we saw publishing to ArcGIS server. And most importantly, I think what we saw is taking our analytic tools, our tradecraft, our knowledge, and being able to package that up and publish that very easily so that others can benefit from that as well. So that's the power of ArcGIS for desktop. Now, if ArcGIS for desktop is the heart of ArcGIS, ArcGIS server is its soul. And ArcGIS server has been massively improved at 10.1. In fact, it's almost been completely re-engineered from the ground up to support 64-bit processing. It's faster, it's more powerful. There's many new capabilities that it possesses, and rather than have me talk about it, I'd like to introduce the ArcGIS server product manager, Derek Law. Derek.
Thanks, Bernie. So first, I'd like to give some context on the vision of ArcGIS for server. As many of you know, ArcGIS Desktop allows you to create and manage many different GIS resources, such as your maps, your locators, and also your models. And the power of ArcGIS for Server is that it allows you to take those GIS resources and you can share them as web services. These web services can then be consumed by a variety of clients, as you saw this morning, from your mobile devices to web applications to even ArcGIS for desktop. So by allowing these web services to be accessible through a variety of different clients, we can do better decision making to solve real-world problems, as Jack described earlier this morning. So for Server 10.1, we have 3 key development themes. The first, we wanted to make it faster, we wanted to make it more simpler, and also more capable. As Jack mentioned earlier, and Bernie just mentioned this as well, Server 10.1 was a significant release. The first reason, of course, is it now runs as a 64-bit process. In fact, you can't get it as a 32-bit process anymore. And testing has shown that functionality is 2 times up to 5 times faster than before. Now, rather than have me talk about it, Jay is going to show you some performance demos. Jay?
Thanks, Derek. In this particular demonstration, what we've done is we've prepared a viewshed model. We really wanted to test the performance of ArcGIS for Server at 10 versus 10.1. So this demonstration uses a viewshed model, which uses a DEM that's freely available from Geographics. We're using aerial photography from Auckland City Council. And for those that live in Auckland, you'll know that this is One Tree Hill. Now just watch, as I execute this viewshed, how long it takes ArcGIS for Server 10.1 to execute versus ArcGIS 10. It is the same viewshed model being executed in both. ArcGIS for Server at 10.1 is substantially faster, and this is due to a number of the improvements as Derek has described. This application was built using the ArcGIS API for Flex. Let's look at another example. This application, built using the ArcGIS API for JavaScript, is a custom app which has a base map and a simple routing service. I click from A to B, and I find a route. We're using the Terralink road network dataset for all of New Zealand, so we haven't clipped it. Now, many users compare our platform to some of the more commonly used applications on the web, and always ask the question if ArcGIS Server can really route in real time. Well, watch as I pick up this route and move it along. ArcGIS for Server is routing this in real time. It's making calls back to the server and recalculating that as I move along. This is simply amazing. What I can also do is, if I'm in the logistics side of things, I can carry out and work with this application and plan my day. For example, quickly putting point barriers, line barriers around the place, or even polygon barriers, and just watch how fast ArcGIS for Server is recalculating this, making my workflows more efficient and easier. I can also bring up the directions which are being returned on every call. So it tells me exactly how to get from A to B, or how long it's going to take me to do that. In the last demonstration that I have around this, we want to look at how fast ArcGIS for Server at 10.1 executes queries. What we have here is about 1,000 or so customers, a few thousand customers that are in the Tasmania region. Now, these are fictitious to showcase this capability. What we're showing here is the number of customers in the view. As I grab the lasso tool, I can actually select and just watch how fast the queries are being returned from the server. Now, we're not just simply returning the amount of customers, we're also returning the revenue, which has been automatically summed up and made available to us. Now, that was only a few thousand customers. Let's take this a little bit further. If I zoom out to get an extent of Australia, the map is about to return over 500,000 points. I can then carry out the exact same workflow, grab that lasso tool, and start selecting on the map. And what you'll find is that the server is returning me those same results extremely fast. So ArcGIS for Server can now handle big data. Derek?
Wasn't that cool? That was like super fast, yeah. The team has worked very hard. So the other reason why 10.1 Server is a significant release, as Bernie and Jack mentioned, is we've changed the underlying architecture of Server. It's now a pure web services GIS server. So what does that mean for you as the end user, right? Whenever you do actions now, everything is done through HTTP. When you publish a service, it's through HTTP. When you query a log file, it's done through HTTP. The install is much easier. In fact, you can install Server 10.1 in 8 to 10 minutes. There's also no more post-install, which is also huge. We've made it easier to configure and manage, and we've added a new REST Server Administration API so you can script with Python or any other scripting language of your choice and automate some administrative tasks. And lastly, Server 10.1 has a lot more new functionality. You can see on the slide we have a lot more functionality than we have time to demo. But what I want to highlight is focus on 3 key areas. The first is in the middle. Due to popular demand, it used to be the #1 software enhancement request on ideas.arcgis.com. We now have out-of-the-box web printing, okay, available for your web clients. We've also improved the web editing user experience. So as you saw Trish demo earlier, that editor tracking capability is also available in your feature services. And we also have ownership-based data access. So if you have multiple users editing the same feature service, you can either enable collaboration or you can restrict editing access between your different users. And the best part about this is the bullet on the left. All of this new functionality is now accessible and you can enable it without having to write any code because we've augmented the out-of-the-box configurable viewers. This new functionality can be accessed in the JavaScript templates, the ArcGIS viewer for Flex, and the ArcGIS viewer for Silverlight. Jay, you want to show this?
Sure. So like Derek said, the ArcGIS views have undergone a lot of updates in the recent weeks. The latest one is the ArcGIS viewer for Silverlight, version 3.0, which was just released last week. And with it came a number of updates. I want to extend Trish's workflow where she published that model to the server and just see how we can now take that to the next level and utilize it in the web environment. In this particular application, I have set up, using the ArcGIS viewer for Silverlight, a view of this particular data. Once again, we have a base map in here and a bundle of store locations. But the first thing I need to do is find a particular store. So I'm going to use one of the new features in the ArcGIS viewer for Silverlight to search for that, and that's the ability to hook into locator-based services. So I know that this particular store is in Woodside Road in Mount Eden. Very quickly, it's made a call off to that locator service, found that result, and zoomed me to that location. Great. I can now continue my workflow. The next thing I want to do is start looking at carrying out some analysis. Now, in a very different way. Trish was more of a power user, using that in desktop. I'm more of a user that just wants to see that end result. I could be a management sort of a user that just wants to visualize that information. What I have here is a little window that's come up. This information has been automatically populated based on the parameters that Trish set in her model. So she said that the facilities needs to be selectable. So the viewer has automatically picked that up and given me a little area to select. The break values, just the service area drive times. In my case, I can change those. I'm using 1, 2, and 3 as drive times. Because we're using the NavTech dataset, this is a time-enabled road network dataset, so I can change the date and the time. And I'm going to execute this. Now this is going to run against that exact same model that was published earlier in desktop, except it's been executed on the server. And what we'll see in a second is the results of this model. I've already configured the visualization of this, so this is why the polygons are returned in this way. I can click on a particular polygon and get that target market percentage, because that's really what I'm after at the end of the day. You can see in that case there was 19%. In this one, 17, and that one, 18. So from this, the target market percentage that I'm looking at between 25 and 35-year-olds, the first polygon is really that one that I want to target into. So that was the ArcGIS viewer for Silverlight. Let's have a look at the ArcGIS viewer for Flex and some of the enhancements there. The first thing you see in this particular example is that it's asking me to log in. Okay, why is it needing me to log in? Well, firstly, we've got a number of secure services that we're working with. Some of this data we don't want to make public. But by logging in, it's also signing up my identity, or it's going to start using my identity as I work with the system. I can now continue the editing workflow that was done in the desktop environment on the web, and we can extend that workflow. What I can do here is I can start digitizing and working with these same layers. As I digitize around, double-click to finish, you see that the attributes have come across as well. Now, remember, these were all set using the feature templates in desktop, It's all being propagated to the web, and ArcGIS for Server is making those available to us. It's a continuation of that system. Selectable values have come across as well. And so his date, time fields, etc. Now, the other thing is, Trish set this up using the labeling to show her username. You can see that my username is in there. Now, I notice up the top here, there's actually a feature that was edited by Trish. I'm going to go and click on that one. But you can see that I cannot edit it. And that's because ownership-based data access has been turned on ArcGIS Server when the service was published. This means that I'm only allowed to edit the features that I created. So if I get into a feature that was this 1 year, this one I edited on Wednesday, you can see that I'm able to modify that. So ownership-based access is a great way of being able to control who edits what. The next thing I wanted to do is do some redlining. Using the out-of-the-box tools, I can do this quite easily. I can select an area to redline and have that draw on top of my map. Now that I have my map ready to go, I want to create a high-resolution print of this. Now, this always used to be a bit of a struggle in the past, or there had to be some custom tools developed in order for this to work. But at ArcGIS Server 10.1, there's a new out-of-the-box print service. The widget within the Flex Viewer has been updated to take advantage of this. You can see that the title field is required. So I'm going to type in here a title, the author being me. The copyright is already being set, so I cannot modify that. And the template. Now, these templates are the templates you define in ArcMap using layout mode, setting all your copyrights, the date, times, what you want it to look like. Now, in Hamilton's case, they've already done this. So I'm just going to utilize one of their existing map templates. In this case, the A4. And I'm going to select the format. I want it out as a PDF. Now, really important is telling the server to give me a print at the scale level. When I hit print, this is calling the server, making a request and saying, you know what, take everything I've got on my map and give me this high-resolution print. And here you could see it in here. It's got the Hamilton City Council logos, it's got the date, time it was printed, all my redlining, and all my edits. Great new service out of the box. Derek?
Thanks, Jay. This used to be the #1 enhancement request that we've listened to you and we've added, yeah. Okay, so why did we change the underlying architecture of Server, right? Obviously, we wanted to make it cloud ready. And at 10.1, ArcGIS for Server can run on public clouds, such as on Amazon. It can run on private clouds, and here in New Zealand, they've enabled it on the IBM Smart Cloud. Or you can have a hybrid approach. So you could have your own private virtual cloud, and you can also leverage services from ArcGIS Online. So as you can see, Server 10.1 is a significant release. We're building on earlier releases, and it's great. We encourage you to check it out. Bernie, back to you.
It's a masterful presentation of powerful new capabilities in ArcGIS Server. I think my favorite one is that owner-based editing. Next, on to the topic of mobility. So if ArcGIS for Desktop was the heart of GIS and ArcGIS Server was the soul, perhaps mobility are the wings upon which it can be carried to others. All right, I'm probably going over the top a little bit, but mobility isn't just about field data collection. Today, every member of an enterprise, of a workforce, is mobile. An office doesn't mean coming into a desk anymore. An office can be anywhere. And as GIS users, we need to support these new patterns of how organizations work. And that means being able to deploy GIS across many different types of devices, through different types of browser applications, and that is a challenge. But ArcGIS can solve that challenge for you, and to show you how this is done, I'd like to introduce a good friend of mine and also a master of mobility, Joe Fraley.
Thanks, Bernie. The use of mobile devices has rapidly increased over the last few years. And this is where people are getting their information first. As GIS professionals, we need to think mobile first. But what does that mean, mobile first? It means when we share content, it should fit on a small screen. It should be intuitive, and it should work when you send an email with a link. So when you want to share maps and analysis, The first question you might ask is, do you need to write code? Too much caffeine this morning. No or yes? If yes, do you write JavaScript? Or do you go native? Let's take a look at these three options. The first option, when you want to share to multiple devices, but you don't want to write any code. You've seen how easy it is to share content using ArcGIS Online. So I've opened the full site for ArcGIS Online on my Windows phone. We see that it doesn't fit on the screen very well. It's hard to navigate. I had to force it to open with the full site on the phone, because that's really not what happens when you go to ArcGIS Online. What really happens, if we switch to my iPhone, we see an application that's built to fit and work on your mobile device. I've signed into my organization, and I can get to my content. I can also get to additional content that's been shared within my organization. And I can see the maps that I've authored. I can select a particular map. In this particular case, it's statistics for New Zealand. And I can open up more descriptive information about that map. I can also quickly use the GPS of the device and zoom into my location. And those nice pop-ups that are authored within a web map can be accessed on the device. And if you like a particular map, it's also easy to share that map via email, Twitter, or Facebook. Another out-of-the-box option using ArcGIS Online for users of Windows phones, Androids, or iOS is to download ArcGIS for their native device. Now, I have a brand new Windows phone running Windows 8. It's from a Nokia Lumia 920. And I've downloaded ArcGIS on this phone. So opening ArcGIS's native application, I've logged in to my account and my organization, and I can get to those same web maps. So you're hearing web map over and over. These web maps allow us to share to these many different devices in different ways. Using ArcGIS Online, it allows us to share information to those devices without writing any code. Moving on to the next option is when you do need to write code. Do you use JavaScript and HTML5, or do you go native? Let's take a look at JavaScript and HTML5. When you don't know what the target device is going to be for your application, you can write your code once with JavaScript and HTML5 and share it to many. This particular application was written with the ArcGIS API for JavaScript, and it consumes the same geoprocessing service that you saw Trish and Jay use earlier to show us accessibility in the Auckland area. We can select the time of day we want to do our market analysis. We can click on the map, and it will execute that drive time analysis and also calculate that accessibility percentage for our target market. Once it returns, we'll get our percentages for each of the drive times, and we also get a map of those drive time analysis. Now, to prove to you that it does work on different devices, that was the Windows phone. Let's switch over to the Droid, and I have the same application open in the browser. I can again click on a particular location or select a facility. Wake it up, and it will execute that analysis. So using JavaScript and HTML5, we can write the code once and serve it to many different devices. The final example that I want to show is creating native applications. Some organizations are standardizing on a particular device. Using the ArcGIS Runtime SDKs, we can build applications for these native devices for Android, iOS, and Windows Phone. And these SDKs allow you to take full advantage of the device's capabilities, like the accelerometer, the compass, or the contact list. Coming soon with the Runtime SDKs is the ability to do disconnected editing that Jack mentioned earlier, these disconnected workflows out in the field. This particular application, I call it a digital notebook, was built specifically for the iPad for me to do data collection of inspections after a flood. We can zoom in and see our information on the map. But let's do something different. Let's take it offline and see what happens. I see my application has now gone offline in the bottom right-hand corner. My base map is switched to an imagery base map. And this base map has actually been provisioned to my device, or to the iPad. So it allows me to continue to pan around and do my work. I can also go in and collect an inspection. Collecting my information, I can go through and edit the attributes associated with this particular inspection, and I can even attach a photo. We can save our edit, and I see in the top right-hand corner of the application that I now have one inspection ready to sync. So let's take the application back online. Oops. Our base map switches back to our online base map, and I can click the button to say I want to sync these edits back to the database, or back to the server. Once that's complete, our information is saved. So using the ArcGIS Runtime SDKs, it allows me to build these native applications for a particular device. To wrap up, the three options when thinking mobile first are: no programming required using ArcGIS Online, whether in a browser or a native ArcGIS application. Second, writing applications using JavaScript and HTML5. Write the code once, share it to many. And last, creating those native applications using the ArcGIS Runtime SDKs. So my challenge to you is, when you need to share your maps and analysis, think mobile first. Back to you, Bernie.
I think my favorite part of that demonstration is that disconnected editing. It's a very powerful feature, and Joe has done a wonderful job of demystifying how we can serve all those needs for our mobile workforce. Now, a long time ago, in the days of Columbus and before, everyone thought the world was flat, but of course we don't live in a flat world after all. Yet many of our maps are flat. We actually live in a 3D environment, and many of our activities, especially those that regard urban planning, design, geodesign, mandate a 3D environment. We've recently released City Engine 2012, which is a new tool which facilitates the cycle of geodesign. You design, you visualize, you analyze, and then you go back. And you repeat the process until you have the results that everyone agrees are the correct ones. Here to demonstrate City Engine 2012, please welcome Zorko Zastric.
City Engine is not only design tool, it also helps us visualize existing data that we have. In this scene, for example, we have data coming from Navtec maps, and we can easily navigate around these 3D models that are, in this example, provided as Collada models. These Collada models are full 3D models with the textures, and we can view them as any other 3D model. So if you do have any existing models, we can use them in City Engine. City Engine can enhance the scene by adding shadows, ambient lighting, just to make it a bit more realistic, or just use it as a simple plain textures. So we can look at various specific buildings done with a very detailed and specific textures or more generic types of textures. If you are in Auckland for the first time and haven't been on a Sky Tower observation deck, here is how that's going to look like when you get up there. It's not always the case that we have existing 3D data. Sometimes we have to start from the scratch. And I've been tasked with creating a whole new subdivision in Auckland. What you see in this scene is a set of parcels, building footprints, road center lines coming from file geodatabase. So City Engine at this very moment is evaluating rules that are assigned to these geometries, and it's creating 3D geometries. So it's a number of different layers that we are currently working on, and you will see them very shortly. So we're starting with very simple point, line, polygon type of geometries. And these rules will evaluate these and create 3D geometries. So here is that scene that I have prepared, and just to start with editing process, I'm going to turn the aerial photograph to indicate the area where I'm going to be creating my new road. To start new road, I will use one of the functionalities of City Engine is to create my streets. This is the starting one, and I'm going to create an entry point, if you wish. So this entry point in that subdivision will be used as a source for using a whole street network. So I have some settings that I can use, and City Engine is now actually creating a whole new suburb for me. So with this suburb, I have two distinguished parts of this. So I have my street center lines, and I have what we call blocks. So I'll work with these center lines first. I can select these center lines and make them rendered with particular rule just to make it nice and visually appealing as a proper road. Next part I'd like to work on is my actual lots, or these parcels that we have created. If you look closely, you will see that some of the parcels don't have access to the road, which is not really a preferred way we do design in here. So what I'm going to do is I'm going to change the way these parcels are created. So one of the options that we have is called a skeleton subdivision, and that ensures that every parcel has an access to the road. But we can also change a minimum area of each of the parcels. So once we have that, we are ready to start visualizing our new subdivision. To do it, I will simply assign a rule for this set of parcels, and these will be rendered according to this particular rule. So now you see buildings getting generated on the brand new parcels I've just created. City Engine also allows us to predefine different what we call style. In this case, I'm going to look at different zoning styles. So I can say for all of these parcels, they will be of zone 6B residential, which has certain settings. So now all of my settings are changed and applied accordingly. So if we go and have a look at some of these parcels, you will see particular information that is displayed, and one of them includes different representations. One of the possible representations is a volume within which building can be created. Planners like that a lot, and they use that a lot. We can also choose just to look at a building on its own, or a combination of these two. So if you do have a building that's sticking out, we know it's an issue. Another important aspect is ability to generate report. So City Engine can create reports for various variables that we can evaluate. So in this case, we are looking at potential values for electricity consumption, parking requirements, stormwater requirements, etc., for these selected parcels. If we select all of them, we will get a total report for this particular subdivision. And looking at this subdivision, you may say, yes, that's all good, but it's not really realistic or the best possible design. And I would agree. So if you spend some time and work with a planning department, you can create a subdivision like this one, which is high density in commercial subdivision option, or look at the option that has lower density residential with a lot more green space and open space areas. We can also have an optional design which includes these volumes for the buildings in either of these options. So now we have these subdivisions created. Next step is to actually put it back into ArcGIS for further analysis. So here we have ArcScene looking at the very same data exported as a feature class. So we have 3D features inside our geodatabase, and here is our high density and our low density option. Having a closer look at this, we will see that there are streetlights generated along those streets. So example of the analysis that we might want to do is to run the models like this one, where we can estimate a coverage of areas for these streetlights generated by the city engine. So once we run the model, we will get buffers that show the areas. We see some gaps here, so it's very easy to go back to the city engine and reduce that gap between the lampposts, and we have modified design. Also, all these elements that I was reporting on in City Engine are carried over as this new feature class. So here we have a table that has summary statistics for all of these features in the subdivision. So we have population totals, requirements for water consumption, electricity consumption, etc. So all these values are carried over. And for the last part of the presentation, what I'd like to show is that we have ability to actually make these designs available to general public. So we have this web scene, as you can see, coming live from arcgis.com, where I have my option A published. I have my option B published. If I want to have interactive look, I can use the slider tool to examine these options more specifically. I can also look at these volumes for the buildings. And I can also use bookmarks to navigate around the scenes very easily. So here is an example of what you can create in here. So we have example of roundabout and left-hand drive roads. So this is the City Engine doing the complete geodesign cycle from City Engine to feature class and back to the web. And that is City Engine.
3D in a browser, pretty interesting, isn't it? Now I'd like to introduce somebody who I had the privilege of meeting for the first time last night, and he's been involved in using City Engine for a real-world case. And this was that of redesigning Christchurch as part of the earthquake recovery process. And this gentleman during the earthquake recovery process was the CIO of the Canterbury Earthquake Recovery Agency, Sarah. So please welcome to the stage, Julian Carver.
Jack said maps tell stories. Today I'm going to tell you just a little small part of my story as being the Acting Chief Information Officer at CERA, using spatial data for a particular outcome. Now this is part of a much bigger story that the Honourable Maurice Williamson is going to tell you about a little later this morning. He'll cover in much more detail the broad range of the way that spatial data was used in the recovery. And I'd like to thank Maurice and in particular his government department, Land Information New Zealand, for the incredible support that they provided CERA in as a startup agency starting up our GIS services. So this story I'm going to tell you in real brief detail now, and then I hope you'll join me for a longer session tomorrow to explain it in more detail. This is a story about a story that we had to tell, a story that we had to tell in 2.5 weeks, which was a pretty challenging deliverable in a short time frame, and how we used City Engine as part of that story. So as you know, we had an earthquake, and there were a whole lot of really challenging aspects to that, but one of those was the demolition of buildings in our CBD. So I started at CERA when it was 20 people and we didn't even have a coat rack, and we had an operations team of about 30 people that were managing the demolitions process. And since that time, we've demolished somewhere around 70% of the buildings in our CBD, depending on how you measure them. Now, that's just a huge, huge undertaking. We required new kinds of equipment to do that. And we ended up with a city landscape that was fundamentally changed. We had to manage information about that. So we had to build new tools to enable collection of data about demolition status, building status, for all of the buildings in the CBD. Fortunately, we had the Christchurch City Council building footprints database to draw from, but even that wasn't complete, so we had to add to it, and we had to build integrated tool chains to deliver GIS data over WFS between their system, which was Intergraph-based, and our systems, which were cloud-hosted Esri-based. So we ended up with this problem. It's an unusual problem to have: too much land. So normally CBDs evolve slowly over time and land becomes available and new developments are undertaken. But if you knock down 70% of the buildings in your CBD and your market analysis is telling you that the market, if left to itself, isn't going to even come close to half replacing those, what do you do? That's a huge, huge challenge. So that was a challenge that the Minister Brownlee and the government took on hand and said, we need to completely redesign the CBD. We need to create a blueprint for the CBD for the next 100 years, and we need to do that in 100 days. So we started with a design team, Boffin-Miskell-led consortium, that it took us maybe 15 of those 100 days to appoint, and we got them on board, and my first task was to make sure that they had all of the data and information that they needed. So theirs wasn't a data gathering exercise, it was a true geodesign exercise. We had no idea, because it was a competitive process, who was going to win, what kind of tools they would be using, what kind of data they would want. So fortunately, we had done some work in preparation, and we were fortunate enough to have a local architect by the name of Jason Mill, who had 3D modelled all of the core buildings in the CBD using Google SketchUp. And we'd already started the process of splitting those out by demolition status, whether they were going, whether they were staying, whether they were maybe going or staying. So we had that model set, and we gave that to the Boffin-Miskell-led consortium, and they used a range of tools, including 3D Studio Max and SketchUp, as part of the planning process. And they ended up, after sort of 30 of those 100 days or so, creating a spatial blueprint and a complete design for the central city that the minister thought was great, that everybody at SERA thought was great, and dealt with those big challenges of too much available land, reduction of space available or space viable for commercial and retail, and the need to create a relivened central city with a heart, and also the need to bring in facilities like a new convention centre and a stadium and so forth. So then we had the next challenge. The challenge was to communicate this plan. We had to communicate this plan to the people of Christchurch, to the people of New Zealand, and the people of the world. We had to bring in a lot of investment capital to make this thing work. And so, basing off that geodesign task involving data on land, value, economics, retail, transport, that had all been modelled and used to create the plan, we now had to communicate it. So we not only had to create a print document, a statutory document, the Christchurch Central Recovery Plan, we also had to create a website that would scale to take massive peak load. And the Minister's office was very clear that we needed to create a video that promoted the story and told that whole story in a really short amount of time. So the challenge we had is we had a 3D environment, we had 3D tools that our people supporting us, Animation Research Limited, were using. And we were able to take those with the blueprint models and the existing models we had and combine them into an environment that could show kind of the past and the future. But as you can see there, we had some gaps. All of the outer buildings, the residential buildings around the city hadn't been 3D modelled. And we needed to do those pretty quickly in order for the video to be compelling. So what we did have was a tool called Esri City Engine that North-South GIS, our providers, were excited about trying out and testing. We had the LiDAR, which let us crunch the building heights and get the building heights exactly. And we had the building footprints. This is showing you now the Esri City Engine using the building footprints and the LiDAR heights to create the buildings, to give them each individual detail, so there was a lot of tweaking that went on to create the peaked roofs and so forth. And then that was handed over to Animation Research Limited, who added textures and brought those into the environment. So I'll now ask them to play the video. You can see the final result.
There is an unprecedented opportunity in the heart of the South Island of New Zealand. On the edge of the sweeping Canterbury Plains lies the beautiful city of Christchurch. Recently, the central heart of this city has faced incredible challenges. In the wake of the 2010 and 2011 earthquakes, over 70% of buildings in the central city have been or will be demolished. But the people of Christchurch have responded with over 106,000 ideas that have informed both the spatial blueprint and the Christchurch Central Recovery Plan. The blueprint identifies a number of key projects that will catalyse development, provide certainty, clarity, and inspire confidence. A frame of open green space will ensure a dense and vibrant core, while the Avon River will create a link between key projects. Living spaces, parks, businesses and commerce will evolve and grow to create a prosperous and exciting central city where people of Christchurch, Canterbury, New Zealand and the world will come to live, do business and experience all that the city has to offer. The Performing Arts Precinct will sit alongside a purpose-built state-of-the-art convention centre. Together, they will form the centrepiece of an exciting cultural and entertainment area in the heart of the city. The hospital will become the focus of the new health precinct. The Metro Sports Facility will be a top-class facility accessible to people of all ages, abilities and sporting skills. With the blueprint in place, the foundation is set for a whole host of successful initiatives. Initiatives based around clearly identified precincts that will attract a vibrant mix of people, commerce, technology, culture and sport. The Christchurch Central Recovery Plan isn't just a quick fix. It's a long-term vision that incorporates cutting-edge design and the latest ideas in urban planning. It's achievable, it's full of potential, and it's ready to fly. Join us in making the most of this unparalleled opportunity to create a central city that will transform Christchurch and inspire the world.
So we were able to make that video. Thank you. We were able to make that video in just 2.5 weeks because of tools like Esri City Engine, because of the courage of New Zealand companies to take on a new tool and try it out and use it for a creative solution. and because of the commitment that we had from everybody involved. So that's just a little taste of how we use City Engine to create this output. I hope you'll join me tomorrow for a deeper dive into how we actually did that and what some of the other uses that we've made of those tools and technologies and we may make of City Engine is in the future. So thank you very much.
It's just an amazing process to what was a very unfortunate situation, and just must be a very daunting task. So it's very inspiring to see how technology is being applied to that. So, and I'm going to try to catch Julian's talk tomorrow. I'm sure it'll be very fascinating. Now, next I'd like to introduce another New Zealand user from the Department of Conservation. Now, this gentleman has been involved with a really remarkable project called SeaSketch. And it's a marine spatial planning tool that leverages the Esri platform and is in itself another example of geodesign. So please welcome to the stage the manager of the Marine Ecosystems team at the Department of Conservation, Sean Cooper.
Great. Great, thank you very much, Bernie. Firstly, thank you very much for the invitation today. It's a privilege to be up here and talking about such a wonderful product and in the presence of a visionary such as Jack Dangermond. So my role is a conservation manager. I'm not a GIS person, but what I did a number of years ago was realise the power of GIS. In fact, my GIS experience is so limited when one of our staff was talking about Python scripts. I had no idea what he meant, and I thought he was talking about the next Monty Python film coming out. Anyway, but since then, I've learned quite a bit. So the Department of Conservation is a government agency that has the responsibility, a statutory responsibility, of managing our conservation estate and our protected species. And in the marine environment, we also have a responsibility, a joint responsibility with other government agencies of implementing a marine protected areas policy. So just as a bit of perspective, New Zealand is a maritime nation. I love this image. It really puts perspective of where New Zealand sits in the South Pacific and gives quite a real, I guess, indication of why New Zealand is now becoming sort of known as Middle Earth. New Zealand is very much a small island in a large expanse of ocean. The yellow lines you'll see there are New Zealand's exclusive economic zone. New Zealand has an exclusive economic zone 15 to 16 times larger than our terrestrial area, and we have the 5th largest exclusive economic zone internationally. New Zealand's marine environment is incredibly important economically, culturally, for social and recreational reasons, and also for our wonderful biodiversity. With a whole range of activities in the marine environment, when it comes to looking at MPA planning or marine spatial planning, when you overlay the particular interests, whether it be economic use of the ocean, community use, recreational use, customer use, scientific use, or conservation uses in the environment, in the past with our MPA processes and forums that we have formed, that has tended to cause conflict in talking about any particular conservation measures that might go forward in recommendations. However, what we wanted to do was explore that space and look at it as the marine conservation or marine stewardship challenge. The space of interacting is, I guess, the area where the possibility of dialogue occurs between all these different user groups. And it's an area that we really wanted to explore in terms of what tools are available to really facilitate that discussion so that we can have true collaborative planning in the marine area. So we searched around, and I was really lucky enough to bump into Will and Chad from the University of California. The University of California had developed a very successful application called Marine Map that was used for the marine protection initiative in California, and was very successful in gaining a whole range of interests, pulling them together using data and GIS as a tool for collaboration. So we contacted the University of California, and Will and Chad gave us a demonstration of how C-Sketch could work. And over the last couple of years, we've been developing C-Sketch with a view to using it for collaborative work in New Zealand. And this is a screenshot of the C-Sketch sort of alpha version. It's still in development at the moment, but the intent is that it's a very user-friendly skin, and also for people like me, it's a really easily usable piece of technology that one of the things for me was very important, that anyone could go into C-Sketch online and use it to be able to put their views across in terms of how we use and manage our oceans. C-Sketch will pull data off the Department of Conservation's web server, which will be published and kept up to date. It also has the ability to pull data off other government agencies or any other website and be able to embed that into a particular initiative. So once again, it's pulling together a whole range of data that can be used for public awareness, for education, for decision making in other areas of the marine environment. But most importantly, what we wanted to use it for was around aiding the conversation around marine spatial planning and taking away the conflict that has been in there in the past and providing opportunity for collaboration. So we've heard a lot about geodesign this morning, and I'm not going to talk much more about that, but it was one thing that really captured my attention when Will and Chad were talking about GIS and the power of GIS for empowering communities to become involved in what we are doing in our oceans or even our terrestrial environment. But essentially, C-Sketch is the tool for us that, I guess, what it does is really show how geodesign can be put into practice. And I have an example here of an initiative off the coast of California, off the coast of Santa Barbara. It's a very simple illustration of how C-Sketch can work. And what this is basically there's a conflict between a shipping lane and marine mammals. And in this particular area, there are a number of marine mammal ship strikes per year. You'll see the shipping lane in the pink there, that's the existing shipping lane, and also the data, the marine mammal data, the observations are in the yellow and the red. Within C-Sketch, what you're able to do is quickly sketch a potential different shipping lane, and what C-Sketch will do will instantly give you feedback on what the conservation outcome and what the economic costs of that particular initiative can be. So we see here there's a proposed shipping lane and the original shipping lane. Now this is the part as a manager that I really love. It's the instantaneous feedback on what positive outcomes there are on biodiversity or conservation. You'll see that with this particular scenario, the interaction with marine mammals has decreased. And what's really important down here is in the instant report, it also gives you the economic costs of what changing that shipping lane are going to be. Now, that's a really powerful tool for a decision maker when it comes to assessing what is going to be appropriate in that situation and what is not. The other really incredibly innovative part of C-Sketch, and this was where geodesign really comes into the fold, it's about reiterating the different designs until you get towards an outcome that's acceptable. And this is the share and discuss option in C-Sketch, where community groups, business can share and discuss their designs, go back and forward, iterate their designs in terms of getting towards a consensus, and then submit a design to a certain initiative. And I think that's really the true power of geodesign and a really good example of geodesign. So at the moment, as I said before, we're still in the process of developing Seasketch. What's coming next for Seasketch in New Zealand? What is really important also is a survey tool. So it's being able to enable the collection of local knowledge, which is very, very important in any decision-making process. Another valuable information in the marine conservation planning area. Once again, for the public, this is a really powerful tool. This enables them to get what is in their head and what is that local knowledge over years into something and mapped and being able to be used. So at the moment, what we're doing and where to next, at the moment there is an initiative for a marine spatial planning project in the Hauraki Gulf out here, and Seasketch, Department of Conservation, Auckland Council and Waikato Council are working towards and anticipating the use of Seasketch in this particular initiative in the next year or so. So I'd just like to quickly acknowledge Seasketch, University of California, who are doing an absolutely fantastic job of developing something that is a really innovative and amazing bit of software. Eagle Technology for supporting the department's work, and of course Esri for developing such an amazing product range. Thank you.
Thank you very much, Sean and Julian, and thanks for making a difference. So this concludes the technical part of our presentation, and I'd like to thank Jay and Zorko and Scott Campbell and Trish Mertz and the rest of my colleagues at Eagle for helping do such a wonderful job of making this a great morning. I hope you enjoyed it. Now I have the privilege of doing something I don't often get to do, and that's welcome back to the stage Jack Dangerman.
Bernie's great, isn't it? He sort of put this whole thing together, of course, with his colleagues here at Eagle, and I appreciate it. Look, we've heard a lot about technology. We've talked about applications of it. We've seen some of that. But, you know, New Zealand is very fortunate also to have somebody like Maurice Williamson at the political level, at the policy level, to not only do all the things he does, but also have the insight to really understand your work. I've had the opportunity to see him talk a few times, but I've also seen his good footprints in the Land Information Organization and census, or statistics as you call it here, and his insights are, for me, profound. He agreed, once again, to be our keynote speaker. Please, ladies and gentlemen, welcome Maurice Williamson.
Well, thank you very much, Jack, and a very good afternoon to you all. Ladies and gentlemen, I know we're running late, so they've asked me will I cut my speech down, so I thought I'll use every second word and then you can multiply it by 2 at the end. The other thing is I feel quite sort of embarrassed to even start. I feel a bit like Madonna's new boyfriend. I know what's expected of me, but how will I make this interesting for you after what you've just seen? You've seen some spectacular technology, which is just amazing. And Jack, I can tell you that even in one of my other portfolios, building and construction, we're moving at sort of light years per fortnight to bring about a whole process of geo-build that I think will make a big change to the way the built environment functions in New Zealand, along with land information as a big project. So I'm going to go through this really quickly. You're not going to get much time to look at these things. You've heard a lot about the beautiful city of Christchurch for those of you who are visitors. Just a couple of shots of what it did look like. Very fast to get you through these. Beautiful city on the bay, and then this is what happened. More than 10,000 earthquakes. The big one on the 22nd of February, a magnitude 6.1, less magnitude than that of September, but it's just to do with where it's located. I thought this was a good statistic for you to know. The energy released from that earthquake was more than 50,000 Hiroshima bombs going off simultaneously, or more than half a year of New Zealand's total energy consumption. The ground shaking was amazing. Vertical ground shaking, the highest ever recorded on this planet, of 2.2 G. That means buildings weighed more than twice their normal weight in the vertical plane, and horizontal shaking of 1.8 G. More than 4 times greater than the highest accelerations recorded at the Japanese Tohoku earthquake in March, a month later. So just to give you an idea of what went on, that's where the first of the biggies occurred out there in the Darfield area. The big one that did the major damage occurred in here around Littleton. And we always expected that the real biggie will come from the massive pressure that's building on the alpine plates up here somewhere, but that's not what happened this time. Okay, so just to give you an idea where it was, 10 kilometres southeast of the CBD, that's the picture of Christchurch taken from the Port Hills, and the photographer took a picture only a few minutes later, and that's what it looked like. So we took a very, very catastrophic shaking, and some photos of the ground will indicate to you just how much movement occurred. If I can just flick back to that, you can see the massive realignment of the fence and the gap in the ground there. So just a few before and afters, what the Avon looked like before, beautiful river, and what the Avon looked like in terms of the level of ground lift afterwards. The Catholic Basilica, a beautiful old building, and what it looked like afterwards. The Christchurch Cathedral, and what it still looks like, and buildings that were there that are no longer there. So whole hillsides falling away, massive damage to things like, a whole lot of stuff falling off buildings. That's the PGC building from the air. 18 lives were lost in that. That's the CTV building, 115 lives lost in that building. And if it hadn't been for the CTV building, which has got a whole lot of question marks about its build, and back in '86, was it actually built to code? Was the engineer even an engineer? There's got a lot more still to flow from that whole process. But if you took that out, we came through one of the world's greatest cataclysmic events with very little damage to our whole city compared to other places in the world that have lost tens, even hundreds of thousands of people in earthquakes of even a lesser magnitude. Urban search and rescue people, we had 150 mobilised almost straight away from New Zealand, but the fantastic support from the international community. 430 came in internationally from Japan, Britain, USA, Australia, China, Taiwan, Singapore, resulted in getting 69 people who were alive out of those big piles of rubble. Look at the size of the huge chunks of land that fell away, and had that fallen just slightly to the left of that, you wouldn't have wanted to be in that building. And the ground that broke open right down through whole seams and right through the houses and so on. A word of in our dictionary now that we'd never had before called liquefaction. I'd never even really heard of it. And now you can just see the most amazing pictures right across the city of what happened to whole suburbs from stuff that just oozed up. 300,000 tonnes in the February earthquake, 300,000 tonnes of liquefaction. If I could show you that, that is the amount of liquefaction that occurred in the September earthquake, and that is what occurred in February. So these maps were really useful. If I want to, I can zoom in and show you. There's in the city, you can see Shirley and a whole lot of the part where New Brighton and so on is. And that's the September amount of liquefaction, which we thought was huge. That's the liquefaction that occurred in the February quake. So we really did look like Beirut in terms of the destruction and the damage. It was a massive event. And once again, I just want to pay tribute to all this. The Japanese people with their dogs, those dogs were just amazing. I was with them in that's the CTV building just in the background. They were just going into that rubble and finding people just, we just can never sort of, the debt of gratitude we owe them is amazing. And to see just streets abandoned, but racks of clothing just still sitting in the streets. And I thought that picture really said it all. Life is beautiful was written on the wall, but there were some people dead in the car. Okay, so that's not what I've come to talk to you about. I've come to talk to you about the three phases that followed it: the rescue, the recovery, and indeed the rebuild. Now, first of all, a whole lot of the information we've been able to use in land information has been about the amazing levels of land and ground movement. You will see there both the black arrows. It's hard to see, but I think you'll get a feeling. There was a massive clockwise disturbance of the land, and a lot of the blue things are how much vertical lift and how much subsidence occurred vertically. That was in the September quake. That was in the February quake. That was in the June one, and when you added them all together, and a massive realignment. All the geodetic positioning points are so far out of line, all the parcel definitions are all got to be redone. There's a massive recalibration required to actually get on and solve the problems of Christchurch. We also used very high definition aerial imagery to help us at both the actual recovery process, the rescue and the recovery process, so you might recognise a couple of these shots in a minute. For example, there's a photo of the buses from above, the buses you would have seen earlier that were crushed by all the falling debris on them. That aerial imagery which we had been flying the very next day, which allowing us to actually at a centralised coordination point look at where things were. There's the Christchurch Cathedral from above, and you can see what that looked like. There's the rockfall behind the Redcliffs Primary School. That was amazing rockfall there, and we were really lucky not to lose a lot of kids there. That's PGC building, I think that is, and that's the one that went on the corner of, that's the building there that disappeared off the corner. There's a bowling green, that used to be a lovely dark green bowling green, just completely full of liquefaction and so on. So we used practical examples and the power of GIS in all three phases. And if I really only want to get away one step, because look, Julian Carver's done most of the really whizzy stuff and exciting stuff, and it was great. And when Trish was showing the maps earlier on and what she could do with them, it was just profound for me in terms of where that will go. I was really rapt to see that she hasn't made Pakuranga join onto the mainland like Apple Maps have. I found that I've lost my whole river and my electorate now joins onto the mainland in Apple Maps. How the hell could they do that, Jack? How could a company that's the biggest company in the world take my whole electorate and join it onto the mainland? Never mind, don't worry about it. Okay, so the Canterbury earthquakes, I think, have done a huge amount to illustrate the value of spatial information, and for us it's been a real learning curve, but it's been a catalyst for kicking us into action for what we'll do across the whole country. They've illustrated just where the critical gaps in our ability to find, to share and to use spatial data were, and we managed to sort of beg, borrow, steal and crimp some stuff very quickly because we were forced to, but it's given us a very good lesson for the future about stuff that's vitally important to have. And it's not just the physical infrastructure. For example, here's some stuff about where the power meters were being recorded in Christchurch and where we were getting redirections and where meters were showing no sign of it. So we could do a lot of information from that about where people were moving out of or disappearing out of suburbs because of it. But we really had a whole lot less information about the invisible infrastructures, the information systems and geospatial information that we will really have to make sure we do a lot better of it. So the power meter information was used to identify houses and area with a likelihood of abandonment. And remember, you've got all of that security stuff. If there are big suburbs being abandoned because of it, police have got to go in and put cordons in there to stop the looting and everything else. The mesh block data we shared with all departments across government and across the Christchurch City Council and the utility providers as quickly as we could. I think the best lesson that came out of the days after the 22nd of February was the phenomenal ability of New Zealanders to be prepared to share anything that they may have thought was proprietary just a little bit before, but get on and do it. The GIS information formed a vivid picture for when people were moving and where they were moving to. Decisions could be made on where to provide community services and support, such as providing heating and amenities and guiding the locations of hubs to connect residents with social services and support. So these were available on the web and people could look at them via mobile devices or by way of desktop browsers. GIS information also provided intelligence on potential areas of fire, because that was always a risk for several days afterwards as to where fire would get hold. Arson, because some people try to do that when these dreadful events occur. And of course the risk of burglary and damage to personal property. This website was launched very quickly in the aftermath of the quakes, showing all that important information such as the status of infrastructure and where services were available, and I'm told by a lot of people in Christchurch it became basically their Bible in terms of helping them through it. And there's a map of Orion, the electricity provider, showing where there was still no electricity in certain areas. So from our maps In real time, we were able to spot where there were problems and how to proceed on. That's where we deployed all of the chemical and portaloo toilets across the place. I mean, it's one of the things you don't really think about, but if your entire sewerage network is gravity-fed stuff and you actually have pipes that are now higher at one end than they were before, lower at one end, you actually can't use them because it's sort of the best way to get your own back. And so you've got to now start using a whole new way of toilets. And there's a map showing where we had deployed stuff and where there was still requirements for that deployment to take more, streets still being poorly served by them. Here's stuff about infrastructure, the bridges, the roadings, everything about the infrastructure. Again, this was coming up really fast for us to be able to use so that when we were diverting, even some of the rescue trucks were able to just make decisions about where they deployed and how they deployed because certain roading networks wouldn't be available for them. And you can go in and click on any one of the pieces of infrastructure there and see what its weight load bearings are estimated at and whether you can use that bridge for putting a big truck onto or not. We also took the parcel land data, which everyone was so keen about, what's happening to my section, what's going on, so you could go and place a pin. Again, I don't have all the whizzy-woo stuff you've seen earlier on, but you could do this, drop a pin onto 38 Hillsborough Terrace and have a look at all of your land classifications, whether it was being classified as fully liquefaction had taken place and unable to be used, or whether it was partially usable or fully okay. And again, people really appreciated being able to zoom in and have a quick look at whatever parcel of land they had and so on. The Canterbury Earthquake Recovery Authority provided a whole lot of maps, both residential and land zoning and some of the CBD red zoning. So here is the zoning of Christchurch going on. You can see a whole lot sitting in that particular map as grey because we didn't know what its category of the land was. Remember, there's a big chunk of the land in Christchurch that will never be able to have buildings put on it again. It is so completely, Jack, this is a new term we've coined in New Zealand called munted. The land is munted, and remember that, take it home with you, the land is munted. And now we're down to, that's about what's left to categorise. You can see all the red zones sitting around the Avon out in the eastern suburbs that will again become parks, aquatic areas, wildlife, whatever, just never going to have buildings on it again. Here's the CBD that we had to put the army, and I didn't put the photos up, but we had fantastic Australian police and army come in within a day, build all of the barriers there, and that's the 4 avenues that we blocked off to the public so that no one could go in. Because when I next day and went in with a whole lot of security people, we went down some streets where there were banks with all their glass smashed open, but all of the tills still sitting there with the money in it, just sitting open. Coffee shops with all their coffee cups and toasted sandwiches still sitting absolutely perfectly where they were. It was sort of almost surreal. So we're down to a much smaller, have a look at this, we're down to a much smaller no-go zone, and we're dropping some of those barriers even as we speak and getting down to almost a hole of access to the CBD, apart from a few buildings that are being brought down, and it's dangerous to have people in around them. This was the technical category maps that my building and housing department have put together so that people can go in and look at where suburbs are, what those various categories of land are. So what land can be, I mean, it's no point rebuilding your building or repairing your damaged building if in fact it's sitting on land that is just going to be totally inappropriate for that use in the future. So the whole point I'm really trying to keep beating the drum on here is that both the rescue, the recovery, and now the rebuild is just centred all around GIS maps and products. I think this was quite an interesting idea. I think you called them thermal or heat maps. Crowd information provided us with some very rich, immediate information to help authorities work to restore essential services and to clear hazards. Such information was used alongside authoritative information to inform the placement of water supplies and those portaloos that I talked about. There's an interesting thing I had never heard of. It's a Swahili word which means testimony, but we set up a Ushahidi site called eq.org.nz, and there people could publicly post to it all of the information that they'd found out along the way, so it was crowdsourcing. The viewer was created using ArcGIS API with Microsoft Silverlight, and it was it loaded a viewer that runs on the fly, hotspot analysis of reports, which can be filtered down to categories if required. So a tool that even 5 years ago, had that earthquake hit, we just would not have had. And that was just the most amazing ability to go and spot where there were areas of need and what to do. The rebuild of Christchurch, of course, centred around this, what we call the Stronger Christchurch Infrastructure Rebuild. So SCIRT has now got all of structure, pipes, water mains, sewerage pipes, everything put in there. You can hover your cursor over any one spot and look at anything of interest to you. All sorts of information about pieces of land and what's being done at this time. So again, just a wealth of information available to all the various agencies involved, as opposed to it being piecemeal where no one knew what others were doing. I'll go very quickly into this. So the size of the earthquake was huge. Treasury estimate about 20 billion, but it's possibly going to be more, about 9.5% of our GDP, so it's the biggest insurable event ever in the world as a percentage of anyone's economy. Just ginormous, and yet, apart from one building with 115, the death toll was quite small. Were vital in the recovery, and they were really going to be vital. They're going to be vital, as you already saw from Julian Carver's presentation in the rebuild. And even on the day, the response team were using these tools, and I thank everyone. I know that Eagle threw a whole lot of technology to help, and so did a lot of other people. And some of your products, Jack, from Esri were just enormously benefit. But I'd have to say the benefit-cost ratio of geospatial was just almost infinite. Without it, we couldn't have done so much of what happened. So now, and let me tell you, there's a paper going through the Cabinet process. I actually took it through the Cabinet Committee last night down in Wellington to look at funding of some new things, which is I guess in a way it's about trying to integrate all based information to ensure that all agencies leading the recovery have access to the most up-to-date information. We found examples for, well, here's just one. I can give you a lot, but in Cashel Street, they've redug it up 4 times for various things in the last couple of months, $90,000 of wastage that didn't have to be wasted had we only done it the once, had each of the service providers, the gas and the water and the electricity. So getting all the information into one place will create significant time savings. It'll allow people to get on and do the real work they need and dramatically free up a lot of agencies. It'll ensure all information is assessed against its location. That's the vital part of all of this. I think when I came in today and saw the very first presentation, we've always known about other data elements, date and dollars and amounts and all those other items of data, but the location piece has been missing, and it's just vital. So we're going to also combine that with regards to our 3D modelling, and you've already seen what Julian Carver said with regards to City Engine and the phenomenal ability to have ministers sitting in that Cabinet Committee room and on the big plasma screens, taking them for fly-throughs and showing them just where layouts were and just where the east frame and where the southern frame would be for the city and so on. Stuff that we've never, ever been able to do before. And then finally, the real big cruncher for me is if indeed we can sort out giving all the people out there that have got mobile devices, and Jack, we're a weird country with 4.4 million people but 4.9 million cell phones. So God knows what happened to the 500,000 that is more than the people, but they're out there. And so we can have that crowdsourcing using the open data and open API support program. People can populate databases with phenomenally valuable information right down to levels of water mains or water main caps missing, etc., and make a real difference. So, connecting the data. In May this year we had a plug fest, was held in Christchurch. It was to explore data sharing using open standards between council, utility providers and the government agencies. The information sharing and updates to data more efficient and to, as I said before, dramatically reduce the duplication, or in fact the quadruplication in many cases. Now I think there's a good example of some of the stuff on one of your display stands here at this particular conference, so I'd recommend you. Is it OGC that's got this? Someone told me there's a stand here that's worth having a look at. Anyway, I'm going to go and have a look at it. I know Canterbury Plug Fest, which came together out of a collectively recognised need to find a way to connect all of this valuable location-based data. So seeing central and local government, industry and interested members of the community working together to find workable solutions, to me illustrates really firsthand just how far we've come in our journey since we first published the New Zealand Geospatial Strategy. The work by that SCIRT, the Stronger Christchurch Infrastructure Rebuild, it's got to be seen to be believed in terms of the information that you can bring onto your screens, the sort of the collaboration that it's providing. It was great to see Esri involved in all of that stuff. It's provided us with some phenomenal tools. But Plugfest, next step. It's all very well to sort of have these great ideas and concepts. Now we've got to move it from the possible into becoming very tangible, everyday solutions. This means doing all the normal ICT work to harden up the solution into an implementation, so that normal users, that's the engineers and data managers, can use it easily and readily, but so can the public. It's about making sure that if the power goes down, these systems still recover quickly and can be operating, because in a time of this sort of emergency, you don't have your normal telecommunications infrastructure and your power. It's making sure that the systems are secure, so that only authorised people can get in and change stuff and make real-time posts and updates. And it's about making sure all of the other ICT policies are adhered to. So the Plugfest has, as I said, led to an increased collaboration between all of the partners in Canterbury, Land Information New Zealand and a lot of other government agencies. That's great. It will generate more efficiencies through all these agencies having access to up-to-date information at the same time without hiring an army of workers to go out and do it. Or having access to real-time data will cut through a lot of red tape, give agencies the ability to make agile decisions and change the direction quickly and easily when a project delivers process is not working. And as I said, the Cabinet's actually right involved in the process of considering that right now. So let me go to the last bit, which you've already seen much better presentation from me by Julian, of actually how we went about designing. It's one of the first times in the world you've been given a sort of a clean slate, fresh palette, and said, now start from here and design a new city. And to actually be able to go and lay out parts of the city and say, this is where we're going to have the health services, this is where we're going to have the innovation centre, this is where we're going to have the conference and convention, instead of the old piecemeal of the evolutionary development of cities that has always occurred, and roads are never fit for purpose because they're too narrow, and traffic hasn't been designed until recently, and it's a nightmare. We've got a opportunity to take it, and I have to say that the tools that Julian Carver demonstrated to you brought every member of the Cabinet almost a look at the new city in a way that would have been just some words on a piece of paper just but 5 years ago. So thank you very much for the opportunity to come along and share with you just my view. I am one of these people who get the religion very strongly when I think it's coming. I pushed very hard in the early 90s that the internet was going to change our lives, and people in the Cabinet then, Bill Birch, used to say, when that fishnet thing of yours comes, it'll make a big difference, eh? Well, it did. I'm not like Al Gore, I didn't invent it, but I knew it was going to make a big change to the world. And the cell phone, of course, I used to say you'll have cell phones on your belt where you'll be able to watch TV and the news and so on, and of course you've got that. And now 3D printing, I've got a lovely little model here, you might like to see it. Julian gave me, this is a 3D print, just off the 3D printer, a full-scale, absolute model of the Price Waterhouse building from Christchurch, so as we build models we can just print the buildings on the printer, any size, so you could print a model this size if you want to make a big room. How cool is that? So you're able to print your buildings just off your 3D printer like that. And all I can tell you is that if all revolutionary things as 3D printing will be, this whole location-based, this whole geospatial, map-based information services and the ability to look at where your customers are, optimise locations, optimise your traffic flows and make sure that you're picking up your potential maximum customer base. You know, we're really on on Schumpeter's S-curve, and I have to tell you, I hope you all, you're an audience I don't need to tell this to, because you all know this. It's other audiences that need to understand this revolution will change absolutely every part of your daily life, and it's just an exciting time being part of it. Thank you very much.
Look, we've been talking a lot about geographic information systems describing the past.
Yeah.
And that's what geography and GIS have really been about. They've been about describing the way things are, or the way they've used to be. And as time integrates into it, we would talk about not so much real time, but sort of slow-mo time. You know, it's static. That's where GIS has been. We're now moving into real-time GIS. And by the way, we've touched on that a little bit during the morning. What you were hinting at is not the past, not the present, not even real time, although that's certainly where we're going. Location services, location-based services will help everybody. But you were talking about the future. And to me, that's the most exciting, which is geodesign.
Yeah.
I mean, tell me more about your vision about geodesign pervasively, because you're building the foundation systems in land and in buildings that describe and deal with cadastre and ownership and all that. What about the future?
Well, Jack, that's the whole point. Whenever we've designed cities in the past, they've been piecemeal. We've done a little bit here and a little bit there, and then suddenly the motor car came along. I mean, we've got the most beautiful piece of real estate in the country sitting down there called the Auckland Port, and it's actually loaded with containers. That's the place where you got the most beautiful views, the most valuable land, and we've got big steel containers piled up. Why? Well, just because historically that's where the port formed. So now to be able to go in and optimally design where you locate those services, and you don't need your containers to have a good view, they don't need to see where they are. And you can actually have a fantastic way. I mean, the tools that this provides us, even just down to your general building, I mean, developing of the new subdivision, wasn't that just the coolest thing you've ever seen? I mean, subdivisions in the past have been, again, some pretty piecemeal things where you've sat down with a bit of paper, said, oh, we'll put a road there, build some houses, and over time we'll hope to put a school. I mean, that is the power of the future in terms of how you go about what sort of buildings, what sort of communities, where you want them living, what facilities you need, how they will access those. It won't just come about by chance. It can be done properly and optimally. My training is in mathematics and optimizing solutions using simplex algorithms and so on. I actually was trained by Richard Bellman on some dynamic theory stuff, and my view is that we've never done things optimally in this country. We've done them just piecemeal historically, and elsewhere as well. Mm-hmm. Christchurch has given us the first chance ever to start with a clean slate, open canvas, begin and do it again, and it will be from that point that I think this will flow further into urban design and so on. Jack, you may or may not know, I want to tell you a quick story. I got involved in GIS optimization long before you had any products in America that we could use.
I didn't think you were that old, really.
Mate, I'm the Korean War, or well, no, I'm not. No. I'm just saying that I was working in the States looking at oil refineries and sources and sinks of where the oils were coming from and where the refineries were, and they were wanting to put the next location. We tried solving it with a massive big simplex algorithm that ran for hours on an IBM mainframe, ran for about 24 hours and still came up with no solution. In the end, guess what we did? This is the first GIS optimal solution in the history of the world. We went to an aircraft hangar, we put a huge big square of jib board, or actually plywood. We had a map of the United States. We drew this map to scale on it in ink. And we then got a drill and drilled holes where each of the cities were, or the locations where all of the sources of the oil was from. We then drew holes where all of the sinks were, etc. We then ran fishing line with Vaseline on it through the holes, and underneath tied fishing sinkers, each weight of it based on the volume of production. So a huge volume production had a big sinker, and a little wee production had a little wee sinker, and we pulled all of these. You're laughing, but this. We pulled all strands of fishing line together and tied them in a knot with a big piece of black chalk. We had it pulled by a crane up to the top of the hangar, set it over the middle of the United States and let it drop. and it actually, because of all the average weighting of pulling, banged the chalk into somewhere in Oklahoma, and many years later when we had the tools to do it, we were less than 30 miles away from the optimal location. There you go, there's your first GI. It's a lot easier now.
Yeah, you could do it with mathematics today.
Yeah, I know. It's a lot easier now, I tell you.
Morris, thank you, and ladies and gentlemen, thank you very much for the wonderful morning. Let's thank Morris once again, and then we're going to break for lunch.
Break for lunch.